Stuart's retired. Good morning, everyone. Welcome to day 2 of SEGHLive. We had a good day of presentations yesterday, well attended by quite a number of people. We've had over 100 registrations from across 35 countries and quite a varied number of backgrounds. We're going to start another program of talks for day 2 very soon. We'll just talk you through some of the introductory comments from yesterday. I'll go through these a little bit quicker, but this is just for some of those people that weren't attending yesterday. We'll give you a little bit of background. Next slide, please. So a lot of this information on the first slide I'll go through very quickly. As you know, SEGH was formed in 1971, and the 50th anniversary celebrations are in preparation at the moment. And we're planning a number of events, workshops, and we may even do more live events like this online. There'll be a series of review papers, so if there's any interest in contributing review papers to this 50th anniversary series, please do get in touch with us. You can find more information on segh.net, and that will be updated as over time. There's an early career researcher group, and Daniel Middleton and Olivier Humphrey will talk a little bit about that at the end of today. And we also have an official journal, Environmental Geochemistry and Health, and we'll give a little bit more information about that and the impact factor and how you can submit papers. 2 international conferences for 2020. Kenya was postponed, which should have happened this week, and is postponed until next year, 2021. And we're still awaiting whether the China conference will go ahead in November. Other smaller initiatives will go ahead. So we had a local meeting in Greece last year, and we may have similar meetings in the future. We're planning a Canada workshop in August of 21. Of course, this is all subject to whether the COVID situation relaxes travel, but certainly we'll think of other formats such as this. Next slide, please. So COVID-19 has led to SEGHLive with us having to postpone the Kenya conference. We very hurriedly put together this meeting, and many thanks to Daniel Middleton and Olivier Humphrey for an enormous amount of effort in putting all of the presentations together and chasing the presenters. Over what has been, I think, 5 weeks or so, we've pulled this together. And many thanks to Anthea Brown, the SEGH Membership Secretary and Treasurer, for also assisting with the registrations. But in particular, Adipo Asano and his team in Kenya for giving us a pool of abstracts that we could call on very quickly. We couldn't have put this meeting together as quickly without their help. And hopefully you'll all be in Kenya next year. And also many thanks to the SEGH International Board, where we have newly elected officials from all of the regions: Asia, Pacific, Africa, Europe, and the Americas. And maybe we'll do another meeting like this. There seemed to be some demand for this type of meeting at the end of yesterday's discussion. So we'll see what today's audience will say. Next slide, please. Oh, that's just taking a little bit of time. Next slide's coming, I think. So I think the next slide, if I remember rightly from yesterday, was a little bit of instructions for presentations. So there'll be 12-minute presentations at the beginning of each major session. They will be followed quickly by 3 minutes for questions to the speaker. And then we'll have sessions of 5-minute presentations, which will roll one into the other. There'll be no stopping between those. And then after 3 5-minute presentations, we'll have 10 minutes for questions. So we will bring all 3 speakers back onto the screen as a panel to answer questions. Okay. If we have some technical issues, we'll try and work through it at the time. And if it's going to be a major issue, we will move on to the next speaker and try and come back to you, just so that it isn't too stressful trying to get yourself connected again. If you are having connection issues today, please let us know in advance, and we will try and rearrange the schedule if we can, so that you have time to correct it. I think the latest slides are coming, are they?
I'm having connection issues.
We're having connection issues, so do bear with us. So I think Olivier's laptop is whirring away, so I think it's just dealing with all of the slides at the moment.
I've not got anything at the moment.
Okay. Okay, so to ask questions, can you please post any questions either during the presentation using the Q&A icon at the bottom of the screen, and then we can have the questions ready for the speakers. That will be a much more efficient way of doing it. You can pose questions direct to the speaker by using the raise the hand icon, and then we will connect you directly to the speaker. Please don't put your questions in the chat box. The chat box is if you want to make some comments, but we won't see the questions if you put them in there, because we're trying to monitor a few different things at once. Okay, and I think are we almost there?
No, got the slides, so we can go straight to Kosei.
Yeah, we'll go straight to Kosei. So I think that's all I had to
Yes.
say. So have a good day, and hope you enjoy the talks. So are we ready to go to Kosei? Yeah. Okay. So Kosei Yamaguchi in Japan will give our opening presentation. So his presentation is entitled "Biogeochemical Release of Arsenic from Lakebed Sediments Receiving an Acid Mine Drainage, Kusatsu Hot Spring, Japan. Roles of Organic Acids and Bacterial Sulfate Reduction." Over to you, Kosei.
Okay, good morning and good afternoon, everyone. And thank you for the introduction. And I also thank the organizers for giving me such a great opportunity to deliver a talk on the first online Zoom webinar of SEGH. Okay, and thank you for reading the lengthy title. Okay, first I would like to show this slide. Here are some acknowledgements to my students and who actually worked on this project, and to some financial support. Okay, well, here is the map of East Asia and the Kusatsu Hot Spring, or Kusatsu Shirane Volcanic District, located in the central part of Japan. Okay, there are some active nearby volcanoes, and therefore hydrothermal activity, hot spring, is pretty much common and popular. And there are some also abundant already sulfur mines. Okay, Kusatsu Hot Spring is actually very popular touristic place in Japan. It is one of the Japan's most famous, ranked #1 hot spring resort, with several hundreds of years history, blessed with large volumes, more than 3,200,000 liters per minute of high quality, really hot spring water, which is said to cure every illness but love sickness and unfortunately SARS-CoV-19. Okay, left is a aerial photo of the area looking down the Kusatsu town with volcano Mount Shirane up there, and recently erupted, and the 3 rivers, 1, 2, 3, flowing from the mountain. The upper right photo shows the crater lake of the volcano, full of sulfur or elemental sulfur, showing its creamy light green color. Okay. Next one. Okay. The rivers with pH 2 or so and high concentration of iron and arsenic are neutralized up to pH 5 by adding lime milk, pulverized powdered calcium carbonate at the neutralization facility in the Kusatsu town. Precipitates by neutralizations are transported to and accumulated at the Shinaki Dam. Okay. However, the dam is quickly filling. The contaminated sediments are transported to nearby mountains. Contaminated sediments are being removed as shown by this photo, and finally transported by dump trucks into the nearby mountains. Okay. Here is a schematic drawing of the processes happening in the area. Just like AMD, acid mine drainage, sulfide in the mountains are oxidized to produce sulfate and to release toxic elements like arsenic here. Okay. Then they are transported through rivers with pH 2 to 3 and neutralized at downstream here facilities to pH 5 to 6. Okay, sulfate, iron, and arsenic-rich river water is neutralized, and arsenic is absorbed onto the surface of the newly formed iron oxide or hydroxide. Okay, the water is eventually transported to Tokyo area for drinking water. Okay, so sediments dumped in mountains would react with naturally occurring organic acids like fallen leaves and so on, and then dissolution of minerals formed by calcium carbonate neutralization are very likely to occur. So serious environmental pollution, release of arsenic and other heavy metals absorbed onto iron oxide may be induced. That's a serious environmental problem. Okay, and here are some photos of the samples and the sampling. Okay, the dam sediments are not actually white or light colored, because the reservoir dam water is rich in sulfate and organic matter. Bacterial sulfate reduction occurs upon the environment became anoxic, and then the sediments color turn into black, very dark here, just like here, right? So the purpose of this study is to quantitatively evaluate the potential by, number one, leaching with organic acid and manure, and number two, bacterial sulfate reduction, and also iron oxide reduction of the neutralized sediment deposited at the dam. If arsenic is found to be released by these experiments, then we need to pay attention, special attention to the fate of dumped sediment in the nearby mountains. If arsenic is found not to be released by this experiment, then dumping of sediments done by local authority would not cause any serious problem. Okay. So here is the flowchart of the experiments. Well, I have little time to talk in detail, so let me skip it. Essentially, we just took the sediment and freeze-dried, and then pulverized and added some organic acid and other mineral acid, and then saw what happened. Okay. Okay. These are the photos of the incubation experiments, right? And they clearly show that the bacterial sulfate reduction did occur. The color of the test tubes changed into the original color to a black, dark color. They are sulfide. Okay. So occurrence of bacterial sulfate reduction was also confirmed by genomic analysis, 16 subunit ribosome RNA analysis. Okay, then here is the plot showing the relationship between concentration of arsenic and sulfate in those test tubes with time. Okay, and at first we had these data points: high sulfate and low arsenic. Then with time, arsenic concentration increased with, and then at the same time, sulfate concentration decreased. This is clearly showing that bacterial sulfate reduction did occur, and arsenic was released upon maybe iron reduction of iron oxide, where arsenic was absorbed onto the surface. Okay. And then these are the variations of our experiments. So the number from A through J, and then we used the neutralized sediment in all the experiment. Then we also used oxalic acid for these experiments, and citric acid for these, and also deionized water, soils, fallen leaves, manure, and so on. And I would like to talk about these dot in red at this talk. Okay, here are the results. Okay, it's not good to show actual numbers in this model presentation, but the time is from 0 to over 20,000 minutes, right? Or 0 minutes to 14 days, 2 weeks. Then these are the numbers of the concentration of arsenic, right? Per 1 kilogram of sample. Okay, and they increased, right, to a significant number. Okay, But oxalic acid made me confused so much. So in the next slide, I will show you the actual plot. But citric acid shows very beautiful, clear increase of arsenic from the from the sediment. Okay. Yes. Okay. This is a plot showing the evolution change of the arsenic concentrations in the test tubes. X-axis is time from 0 to 2 weeks, 14 days, and y-axis is the arsenic concentrations released by this experiment. Okay, and we use two different concentrations of citric acid and also oxalic acid. Well, the data in the brown lines shows the changes in the arsenic by oxalic acid. This is kind of a mess, so it is really hard to interpret. But one possibility is that it may have induced some complex redox reactions. I don't have time to explain these, but the concentration of arsenic was not stabilized at all. But on the other hand, citric acid showed very clear changes, increase with time, from this value to up to about 500 ppm eventually. Okay. But very dilute citric acid resulted in very small amount of arsenic released, and also citric acid too. Okay, 12 minutes. Okay, here the last two. I have last two slides. Okay, here are the plots showing the relationship between iron, aluminum, calcium versus arsenic, right? And then blue symbols citric acid leaching by citric acid, and reddish symbols are by oxalic acid. Okay, for citric acid, covariations among arsenic, iron, aluminum, and calcium clearly showed. Okay, as arsenic adsorbed onto iron and aluminum oxide is released and stabilized by chelate processes, probably. Okay, 2 minutes. So I would like to jump in the next slide. Conclusion. Conclusions. We confirmed significant release of arsenic by organic acid from dumped sediments. Then we also confirmed effective arsenic release from the sediment by citric acid rather than oxalic acid. Then arsenic release by bacterial sulfate reduction coupled with probably iron oxide reduction. And we call for careful treatment of the neutralized sediments and continued monitoring of the dumped sediments. So we have some ongoing studies. Okay, so it's 5:13, so it's end of my talk. Okay, thank you for your attention.
Thank you, Kosei. It was a great talk. I'm not seeing any questions on the Q&A. Michael, do you have any hands up?
No question means full agreement.
Yeah.
I'm seeing some. Yeah. Okay.
Oh,
so
one hand up. Hold on. Let me just find
Okay.
this person, and I'll. So it doesn't give the name. Nokia 6.1 Plus. Let's see who this is. So the person with their hand up, could they ask their question?
Hello, good morning. And good
You'll
afternoon.
need to speak up, please. And could you give your name?
Hello.
Yeah, go ahead.
Can you hear me now?
Yes, that's much better.
Okay, thank you. My name is Giorgio Coco. I'm a student from Toledo University. So what are some of the complex redox reaction you mentioned in your discussion part of the presentation? I'd really like to know about that.
Well, simple answer is I don't know. I don't know very much. Okay, these are just candidate, right? Oxalic acid may have been oxidized to this form, and then some ion redox transformation did occur at the same time. But I homogenized the samples, of course, before the sampling from the test tube, but I don't know why arsenic concentrations changed so much. Okay, the first increase would be also, of course, a release of arsenic from ion oxide. So the then initial decrease may be reabsorption of arsenic onto the newly formed iron oxide, or maybe experiment. It is also possible that experiment did not go well. So I have to confirm this this part, but it's difficult to interpret. I have no idea. I'm sorry.
Okay. Okay, thank you for that. I'll also try and read up upon that when you release the presentation documents. Thank you.
Thank you very much.
Thank you, Jojo.
Had a few questions come through on the Q&A. So Sanya is asking, was your batch process with stirring?
Yes.
And Sanya has also asked, did you perhaps consider mass transfer issues with the oxalic acid anomaly?
Well, mass transfer issue. I have to check it.
I also have a question from Alekos, which is, do you have monitoring stations at the dumping sites?
Well, only pH is continually monitored, but not for trace metal, trace element concentrations, only pH.
I wonder, Kosei, are there any guidelines for people using these springs? Are they aware of the possible hazards in them?
Well, this is just water in the reservoir or dam, okay, and we cannot compare the quality of the water in the dam with drinking water, but obviously arsenic concentrations in this water samples are pretty much high, several thousand times higher than the WHO recommended level of 0.01 ppm.
Yeah,
right.
Yeah. I suppose it depends on the exposure and how much people are ingesting. Do we have time for other questions?
We've had a hand up for a little while. Should we just take this as the last one, and then we'll need to move on? So if we can ask Adam Sadiq for his question, please. You just need to unmute yourself. There you go.
My name is Adam.
We can't hear you. Can you speak up, please?
Hello, good morning.
We still can't hear you.
Hello.
Too small.
Hello.
Okay, we're going to need to move on. So we can't hear you. You have a talk in 2 presentations. So can you please arrange your microphone? And I think we need to move on to the next presentation, don't we? So we're now running behind. Okay. Many thanks, Kosei. That was a very interesting presentation. Thank you. And so now we move on to 3 5-minute presentations. We will hold the questions at the end of these 3 5-minute presentations. Okay, so we have 10 minutes set aside for that. So Dan will give you a warning with 1 minute to go, just when your time is running out. Okay, so the first of these 3 5-minute talks is by Mahmudo Ibrahima from Mozambique, and his presentation is entitled Manipulation of Soil Fauna, Termites and Their Allies, Decomposition Agents for Sustainable Food Production Under Climate Change.
He's not here yet.
Is he not here?
He's not a panelist yet. He has been promoted to a panelist.
Okay, so we're just waiting for him to appear on screen.
There we go.
Mehmet, can you unmute yourself so that you can deliver your presentation, please? Could we just, as a reminder to the other presenters, just check that your microphones are working, please, later on. Mohammad, we can't hear you. Have we got him on screen?
He's on screen, he's still muted, he hasn't started his video either.
You're right. Can you put your... Mohammad, can you unmute yourself, please? I see what you're doing.
Should we start with Adams while we're waiting?
Yeah, we're going to have to go.
Yeah. Okay, let's move to the next speaker. We'll get Mahmoud back in a few minutes. Okay, so we're going to move to Adam Sadiq, who is ready. And Adam Sadiq is from Ghana, and his presentation is entitled Assessment of Heavy Metals and Nutrients Status at a Reclaimed Mine Site. So over to you, please.
Yeah, good morning. Please, do you hear me? Please, can you hear
Speak
me?
up, please.
Into the mic.
Hello, good morning.
Speak into the microphone, and if you have anyone speaking near you, please ask them to be quiet for 5 minutes.
Good morning. Please, can you hear me? Hello?
Just about.
Hello?
Okay. We can just hear you.
Hello, can you hear me?
Yes. Go ahead.
Okay, good morning. Good morning. My name is Adam Sadiq. I am speaking from Ghana. My presentation is about the assessment of heavy metals and nutrient status at reclaimed mining sites. Please, next slide. The next slide. The objective of this research is to analyze soil, plant, fruit samples received from Taka goldfish to determine the nutrient status and heavy metals in the study site. This next slide. In fact, we received 165 samples at the study site, which included citrus, oil palm, and then soil. This next slide. The research took place at Takwa Goldfish Limited, which is in the western side of my country. And then standard laboratory protocol for soil and plant analysis were followed. Next slide, please. Hello?
Yeah, go ahead.
Hello?
Okay. I think he's frozen. I think we need to... Adams, can you...
Hello?
Hello? Go ahead with your presentation. Carry on.
Good. After the analysis, as you have shown on the screen, the following findings were made. Soil fertility level was low, as indicated by cation exchange capacity. Generally, heavy metal content in the soil sample were below the maximum allowable limits, except mercury, which was above the allowable limits. Heavy metal content in the plants were also within the allowable limits, except for lead and cadmium level, which were above the allowable limits. Next slide, please. Recommendations. To improve soil fertility for sustainable crop production, management practices that promote accumulation of organic matter, such as cover cropping, soil and water conservation, application of organic fertilizer and inorganic fertilizer and organic fertilizer are recommended. Sources of these pollutants should be reduced to the barest level, which will not harm the risk of human life. Next slide, please. Thank you very much. This is my profile.
Great. Many thanks for your presentation. Can you stay online, please? And we'll have the presentations for the 3 talks at the end of this session. Okay. So
Okay.
we'll go back to Mamad for now. Okay, Mamad, are you ready to give your presentation? Okay. So there we go. We gave you an introduction a few minutes ago. If you can start your presentation, please. Is he on mute? Can you unmute yourself, please? You are still muted. Mamad, you are still muted. So you should have an icon in the bottom left corner of your screen. There we go. Away you go.
Okay. Next slide for. Yeah. This is my experiment. You see the rest of the catchers when you very quickly. Soil sampling, collecting the material by termiting the rest of the catcher in different locations to analyze the soil immediately in soil laboratory. We will present it to 3 parameters: pH and the organic matter and phosphorus. Next, please. Yeah, can you see the numbers? This soil in Mozambique is very poor in phosphorus, but this material, rest of the culture from the termity is very good material for phosphorus. But you can't see the organic carbon is very low. My question is possible to determine the latest carbon in soil incorporated by termites? Can see the pH is very high. It's good material, but very low the phosphorus, the organic matter is very, not visible what termite incorporate in our soil. This is very important for our soils. Next. Next, please. Yeah, the organic material, when it's thrown to soil, included cutting it, not scalp process disinfect. The review, this scalping the, please read the review. I'm provide the initial batch for practical works. Never been concluded this amount. Then part of the latest carbon immediately. Method carbon is analysis. What we analyze is is possible to detect it, because this eternity introduce more carbon. It's is very, very high activity in the rest of cultures, because it's difficult to determine how amount carbon incorporate in soil. It's very important to study this in rural communities, because this area, when you have more termites, is good area for cropping. Next. Conclusion, soil are fertile, but low carbon content, the latest. Next. Next. This is material. Okay. Man, thank you. Yeah, this is material one use, because all this involved only take this involved to analyze, in lab this material.
You have 1 minute, Mamade. 1 minute remaining.
Yes.
It's okay. Yeah, 1 minute.
Yes. Yeah. Last is next. Many thanks.
Many thanks for your presentation. Can you stay online and we'll take questions for all three of you? Okay, so stay where you are and we'll come back to you. Can you mute him? Yeah. Okay. Right. We're going to move on to the next speaker in this session of three presentations, Lucy Wanjohi from. Sorry if I mispronounced your name. From Kenya, whose presentation is entitled "Use of Multi-Stage Phytoremediation Technique in Wastewater Treatment." Over to you, Lucy.
Thank you very much. I'm Lucy Wanjohi from University of Eldoret, Kenya. And my project was on use of multi-stage phytoremediation technique in wastewater treatment. Next slide, please. There has been a growing concern for the diminishing supply of clean water and potable water in Kenya. And this water pollution has become a prominent environmental problem affecting the quantity and quality of utilizable water. And in order to be able to curb this problem of water scarcity, the most sustainable solution is to treat wastewater into high quality water. Efficient treated wastewater can act as a solution to the problem of water scarcity and also water pollution and wastewater disposal. Hence, there was a dire need for information and development of low-cost water treatment technologies that will provide a solution to these water challenges. Hence, there was need to carry out this project, this research, in order to see whether we can be able to use phytoremediation technique to clean wastewater. Next slide, please. Phytoremediation as a method of wastewater treatment has been applied successfully in remediation of contaminated aquatic environments. And to clean up wastewater using this method of phytoremediation, there is need to select appropriate and efficient plant systems that are highly essential. Also, the arrangement of these plants in the technique is very important to ensure that the method is efficient. This promoted the search for best local plants from the region to be able to clean wastewater. The technique that was chosen was multi-stage phytoremediation, which is less investigated. Next slide, please. The study was carried out in University of Eldoret, Kenya, and the experiment was a 4-stage treatment system. It comprised of 4 columns with different arrangement of macrophytes. The local macrophytes that were selected were Stratophyllum damascum, Typha ratifolia, Nymphia species, and Azora pinnata. Wastewater was collected from the University of Eldoret sewage plant. It was put in 4 20 sterilized plastic containers, and it was allowed to flow from the plastic troughs to the plastic troughs that were containing the experimental plants. So it was able to flow from stage 1 to stage 4. And the retention time that was there was 5 days. Next slide, please. Water indicator parameters were analyzed. They included the physicochemical parameters, the bacteriological parameters, nutrients, and heavy metals in the wastewater. This was done before, when the water was sampled from the sewage plant, at the beginning of the experiment, and then after 5 days retention period, and this was done for 20 days. Standard methods were used to analyze the mentioned parameter, whereby the phosphates were analyzed using ammonium molybdenum method, nitrates were analyzed using brucine method, and heavy metals were analyzed using nitric acid digestion method. Means of the mentioned parameters were calculated. They were analyzed using ANOVA, and significant means were separated using Tukey's test at 5% level. And then after that, the removal efficiency was calculated. Next slide, please. These are the results of the analyzed parameters, whereby the physicochemical parameters that were analyzed, the TDS, pH, conductivity, and turbidity, the removal efficiency for TDS ranged between 79 to 82%. For pH, it ranged between 14 to 16%. Conductivity, 66 to 71%. Turbidity, 67 to 80%. For the bacteriological...
1 minute, Lucy. Sorry, 1 minute.
Okay. For bacteriological parameters, Streptocoriforms range was 63 to 72%. Ficocoriforms was 100%, and Ficostreptococcus was 100. Heavy metals that were analyzed included cadmium, which was removed by a rate of 83 to 100%, copper by 83 to 88%, nickel, lead, manganese, and zinc was 100%, whereas iron was 88 to 95%. Next slide, please. The multi-stage technique was found to be efficient in wastewater treatment, hence can be applied. The technique was found to have a good purification effect and low cost, and had low cost in operation and management. And therefore, this technique is recommended as a green technology, which can be used for efficient and economical treatment of wastewater, especially in the developing countries. Thank you.
Many thanks, Lucy, for an interesting presentation. So we'll take questions from all 3 presentations now. Dan, do you want to lead on the questions?
Yeah, I have a few that have come through in the Q&A.
You have 2 hands up, so we can come to those afterwards. Okay.
Apologies for the pronunciation. Thembinocosi Mbedzi. Hello, Adams. This is for Adams. If you'll unmute yourself, please, Adams. Research has shown that heavy metals from reclaimed mine sites get absorbed by crops and vegetables, making them unsuitable for human consumption. What is your comment?
Again, the question again.
So the question was,
hello?
Can you hear me, Adams?
Yeah, I can hear you.
Okay, the question was, research has shown that heavy metals from reclaimed mine sites get absorbed by crops and vegetables, making them unsuitable for human consumption. Can you comment on this?
Yes, in the mining areas, these heavy metals are very dangerous, and when they reclaim the mining site, and then please come again. The questions are not. It's not clear.
I think it was just maybe a comment, but I can move on. I have another one for you here from Alistair Kirulf, which is there any plan to conduct bioaccessibility analysis on these soils? So do you plan to do bioaccessibility assays on the soils?
But I have no idea. No, I have no idea about this.
Okay, maybe perhaps that's something the 2 of you can connect on later. I have a question here to Lucy. Do the water physiochemical parameters have any impact on the phytoremediation process? And if so, in what ways? And this is from Nokia 6.1 Plus.
Water is found to have some phytoremediation effects. For example, you find that when you're using plants like those ones like cytophyllum, you find that it is a submerged plant. So when there is a lot of turbidity, then this plant cannot be able to perform well because turbidity will make the plant not to be able to carry out photosynthesis well. So as a result, then you find that those physicochemical parameters has an effect. Also pH, when it's in excess, it can make the plants it affects the plants. So you find that the efficiency of phytoremediation is reduced.
Okay.
Right, Dan, okay, we've got 2 hands up that we've had all the way through the session, so these will need to be the last questions. Okay, because we'll need to move on. We have a question from Collins and Gori, so you can go ahead and ask your question. And can you say who the question is to, please?
Thank you. My question goes to Lucy. I have 2 of them. The first one is, would you recommend this technique for all stages of wastewater treatment? Remember, we have primary treatment, secondary, and tertiary. So would you recommend phytoremediation techniques for even the primary treatment? And the second question is, you have Azolla pinnata, Ceratophyllum damasama, among other macrophytes as your candidate species for these tests. But I feel my problem is, would you consider water hyacinth among these macrophytes for your test, given that water hyacinth is a problem in this region? And this could, maybe the outcome of such a test would address the problem as form part of the remedies to water hyacinth problem around here. Thank you.
Thank you very much for that question. The first one, where the phytoremediation, whether it can be used in the primary stage, yes, in some areas where there is no other method that is being used, it can be applied to even clean the water from the first stage to the last stage. But where we have other techniques that are being applied, I would say that it is best to apply it after tertiary stage, whereby if at all maybe the methods being used are not very effective, then phytoremediation can be the last one to aid in the final purification of the water before you release it back to the water, to the river or the other aquatic systems. Then concerning water hyacinth, yeah, according to the literature, water hyacinth is very effective also in phytoremediation. It has been used. But for my case, I was not able to use it because where I'm working, there is no water hyacinth. And therefore, I couldn't transport it to this site to avoid introducing it to the environment in this site. But otherwise, it is also effective.
Thank you.
Thank you. We have one last hand up from Noor. So I'm just going to enable you to talk. You can ask your questions, and this will be the last one. Are you able to speak, Noor? You need to unmute. Okay, unmute. Bottom left corner. There you go.
Hello?
Yeah. Ask your question. Can you speak loudly, please?
Yes, my question, I wrote then, my question was if she knows the mechanism of removal for the heavy metals using these plants. Lucy.
Some of the methods that I was able to get from the literature is that there are some that use phytoextraction. There are like 4 techniques that are used for extraction of the heavy metals. One of them being phytoextraction. That was the one that I saw applying in the experiment that I carried out.
Thank you.
Okay. Many thanks to the speakers so far, and well done for overcoming some technical challenges. and we'll move on to the next series of 5-minute presentations. So first, again, we'll take questions after these 3 5-minute presentations all at once. So the next speaker is Marietta de Tuit from South Africa. Presentation is entitled Analyzing Trace Elements in Sediments Using Energy Dispersive X-ray Fluorescence. Over to you, Marietta.
Good morning, everybody. Sorry, my video system's not working on my laptop, so unfortunately you won't be able to see me. My name is Marietta de Tuit. Can everybody hear me?
Yes, we can hear you clearly.
Okay.
Thank you.
I'm the X-ray product specialist for Spectra in South Africa. Spectra is a worldwide, world-class manufacturer of spectrometers for ICP, arc spark, and X-ray. And we are responsible for all the sales and services of the Spectra equipment in Sub-Saharan Africa. The focus of the talk today is analyzing trace elements in sediment using EDXRF. Next slide, please. Energy dispersive X-ray fluorescence is an acceptable technique for elemental analysis of sediment. This is due to the instrument's stability and ease of use, which let them excel at critical tasks from rapid screening analysis to precise elemental determination. They provide fast, precise, accurate, and economical solutions for analysis of major, minor, and trace elements and these and similar applications. Next slide, please. Sample preparation for trace elements, standard reference materials in a dried fine powder form with a grain size of 60 microns were used. 5 grams of this dried powder was mixed with 1 gram of wax, and the powder was then pressed in a steel ring to a pressure of 15 tons to produce the final pellet. Next slide, please. The measurement was made using a Spectra Z-Pulse simultaneous EDXRF spectrometer. The instrument is equipped with an air-cooled 50-watt end-use X-ray tube. The tube anode consists of a unique thick binary alloy of alloy and cobalt. The analyzer features a large area high-resolution silicon drift detector, a fixed excitation optic, and a filter charge changer in front of the X-ray tube. The highly stable spectral resolution of the SDD detector amounts to less than 130 electron volts at the manganese K alpha, and the input rate was around about 1 million counts per second. Next slide, please. The Spectra TurboQuant 2 software, which specializes in identifying unknown samples, was used. The software combines the mass calibration of the absorption coefficient of the Compton scattered palladium K alpha line via Compton intensities. These intensities was corrected for volume effects as well as the matched fundamental parameters approach to calculate the absorption and the enhancement effects within the sample. The graph below shows the calculated mass attenuation coefficient versus the given mass attenuation coefficient. Next slide, please. Fundamental parameters were used in the second part of the calibration. For the purposes of this presentation, I'm going to refer to the element rubidium only as it is a trace element in sediment. Traces are defined as less than 1,000 ppm according to the geochemistry, but analytical chemistry define it as less than 100 ppm. From the fundamental parameters calibration for rubidium, we can see that the LOD achieved was around about 0.7. The maximum concentration range for the calibration was 9,000 ppm. 64 standards was used. A correlation coefficient of 0.9999 was achieved, and the relative standard deviation over the curve was 23 ppm. Next slide, please. From the analytical performance, we can see that rubidium's given concentration for the certified reference standard SDAR-M2 is 149 ppm plus minus 2 ppm, and the analyzed value on the X-ray achieved was 147 ppm. Next slide, please.
You have 1 minute, Marietta.
Okay, good. From a repeatability perspective, the certified reference standard GSD-14 was analyzed for 5 times in 1 day, and the average analysis value was 82.5 ppm versus a certified value of 87 ppm plus minus 7 ppm. Next slide, please. The SpectraZBOS simultaneous EDXRF spectrometer provides a fast, accurate, and economic solution to analyze major, minor, and trace elements in sediment samples. Very high spectral resolution, exceptional low detection of limits were reported for most elements tested. Calibrations based on a well-characterized sample showed very good correlation for a wide range of elements. With the data that we provided, we've proved that the energy dispersive X-ray can analyze traces and sediments with the required accuracy and precision. Thank you for your time. I'm done.
Okay, many thanks, Monita. We'll move straight to the next talk, and if you can stay around for questions, please. It's a series of 3, and we're over to Akinad Olatunji in Nigeria. His presentation is entitled Essential and Toxic Elements in Soil and Plant Samples and Their Transfer to Rice Grains of Itukin, southwestern Nigeria. Over to you, Aki.
Yeah, thank you very much, Mike, and good day to everybody. The title is as shown on the screen. Next slide, please. The Nigerian population is a rice-consuming population, and the per capita consumption is 32 kg. And in the last decade, this consumption has increased rapidly, with Nigeria now accounting for 20% of the whole of the African continent consumption of rice. As at 2011, 10% of the household food spending in Nigeria is used on rice. And it is also recorded that rice production reached a peak of 3.7 million tons in 2017. The map you are seeing on the right-hand side is a PricewaterhouseCoopers generated map to talk about the Nigerian rice industry at a glance. Next slide. Now, if you look at the various charts that are shown in this slide, you see that there has been a progressive increase in the domestic milled rice consumption from 1960 to 2018. There has been an upward increase. And if you look at the next figure on the right as well, you see that the production consumption rate have not been matching one another. So the production level had been below the level of consumption, meaning that Nigeria has to resort to importing a lot of rice from outside the country. And the next 2 figures below also shows the comparison of Nigeria with some other countries in terms of the total consumption of rice and total production. And you see Nigeria on the far right there, we have 7 as the total consumption reached 7 million metric tons compared to 4 million metric tons that is being produced locally. And if you look at the other one, you see that other than China, Nigeria is next in terms of the top rice export and import countries in 2018. Next slide. As I also mentioned earlier, you can see that there is no match between consumption rate and production rate. The production level has been increasing, but similarly, the consumption level has been increasing. Now, because of this has also have a very big impact on the finances of the country, and the country has now embarked upon a local aggressive production of rice. And you can see from the map on the right-hand side showing various states of the federation where rice is currently being grown. Next slide. Now, what are the challenges? In the short survey that was undertaken late last year, we, from 616 respondents, we observed that at least over 30% of the respondents indicated that they consume rice daily. Another over 50% said they take rice twice daily, while about 50% of the respondents said they take rice at least 3 times in a week. And that shows that Nigeria is actually a rice-consuming nation. And because of that, it is important to begin to look at what this nutritional quality of this rice that Nigeria is consuming all about. Then the map there shows the division of the various breakdown of the rice grown in Nigeria in terms of hectarage that is cultivated and harvested, depending on which part of the country we are looking at. The current study is actually in the Rainfed lowland area in the southwestern part of the country, in Lagos. Next slide. Now, we have read, it is established in several reports, especially the one that have been published from the Asian nations of India and Bangladesh and Thailand, that rice had been indicted as a major pathway for the introduction of potentially harmful elements into the food chain. And
you have 1 minute, Aki.
With the upsurge in the rice production, it is important to have a clear look of what this rice is all about. Okay, next slide. Don't worry. Yeah, that is just the methodology that was adopted. Next slide. These are the physicochemical parameters of the soil samples from each of the field. Next slide. Now, this is the mineralogy of the soil from the area, mainly dominated by quartz because it's a sedimentary environment. Next slide. Now, this is a summary of the elemental analysis of the result I was getting. The first section shows the essential element, while the next section shows the toxic element content in the rice and in the rice plant. Next slide. Now, this is the transfer factors calculation between the essential element and the toxic element, and we'll find that there is a significant movement from the soil into the plant. Next slide. So these are the observations. For soil, you have your major elements, and for plants, you have your macronutrients that is shown. Then your rice grade, you have your macronutrient that is shown. If you look at the transfer factors, it shows that there is a kind of increase in sulfur, move to calcium greater than magnesium and the rest. Same thing with the other one. Next slide.
If you can wrap up within the next 30 seconds, please.
Yeah, I'm actually wrapping up. This is the last slide. Now, the study shows that the soils generally were not polluted. The soils of these grades were not polluted when you look at the standard of other countries. Now, the pHs were also taken, about less to be taken because of the pH of the soil. But on the basis of nutritional assessment, the rice is said to be at least enriched in molybdenum, copper, manganese, while it's deficient in calcium, phosphorus, and selenium. So it is important that we begin to look for a way by which we can fortify the soils with some of the deficient elements in the soil. Thank you very much for your attention.
Many thanks. Just if you can stay online for questions, please, and we'll move to the next 5-minute presentation. Job Isabuki, and oh, this is a long title. The impacts of 2,4,5-trichloro. I can't see all of the title on my screen, so sorry, I'm going to read that again. Trichlorophenoxyacetic acid on the metamorphosis of Xenopus laevis and the remedial capacity of ascorbic acid. Is that the African clawed frog, I think?
Yes, it's African clawed frogs.
Okay, over to you, Job.
Thank you, Dr. Michael. My name is Job. We have been working with the project on the impact of 2,4,5-T-chlorophenoxyacetic acid on the metamorphosis of Xenopus laevis and the remedial capacity of ascorbic acid with Professor Dipo. Next slide, please. Herbicide 2,4,5-T is an example of a toxicant that elicits toxicity in animals by oxidative reactions. Also a common square for metabolic reactions. 2,4,5-T is a synthetic auxin that is used to defoliate broadleaf plants. I wanted to counteract the impact of 2,4,5-T using ascorbic acid, which is a natural occurring organic compound with antioxidant properties. The ability of ascorbic acid to reverse toxicity due to oxidative reaction is tested in this project in 2 ways. There is FITAX assay and the AMA assay, but I measured into AMA assay, which is amphibian metamorphosis assay. The ability for the frogs, that is Xenopus laevis, to evaluate antioxidant effects of the compound is also tested here. Next slide, please. This is my short methodology, how I worked on it. The amphibian metamorphosis assay is a standard procedure which was outlined by OECD in 2009. The general experiment design details Xenopus stage 51 laevis tadpoles to a minimum of 3 different concentrations of a test chemical and a dilution water controlled for 21 days. On my left side, it is a 51 stage tadpoles that I exposed. They are pictured under microscope. Then on my right side, it's a female and male Xenopus, which I injected with an hormone, HCG hormone, to get the eggs, which I reared to the tadpole site. On the middle is a test media, how I laid my experiment into duplicates And also I have a control with 2,4,5-T, control without 2,4,5-T. Then the last 4 has different concentrations of ascorbic acid with 20 microliters per liter of a 2,4,5-T. Next slide, please. My results are 67% of the tadpoles exposed to 2,4,5-T, that is 20 micrograms per liter of 2,4,5-T, died. The tadpoles succumbed due to disturbance of chemical equilibrium, according to Plazat at 1983, caused by the herbicide. It also delays the metamorphosis of the tadpoles, whereby 27% of the animals exposed to 2,4,5-T developed hind limb buds. In the table, you can see how the 2,4,5-T affected, because the control with 2,4,5-T has high percentage of mortality compared to other controls. Introduction of ascorbic acid reduced the rate of mortality. Low concentration of ascorbic acid reduced the stress caused by 2,4,5-T, hence increased the chances of survival due to oxidation reaction properties. This is whereby ascorbic acid introduces as a property of detoxifying reactions by use of ascorbate reaction, which is a conjugate base of ascorbic acid, which arises from selective depolarization of 3 hydroxide groups. Then next we have a high concentration of ascorbic acid also is dangerous to animals, whereby it causes a gastrointestinal irritation, which increases the stress to the animal exposed to, hence more death of organisms, as seen in 60 and 80% of the experiment, respectively. Next slide, please. 1 minute, Job. The tadpoles you see here are picked from different concentrations of ascorbic acid and also 2,4,5-T. Tadpole 2, tadpole T1 was the ascorbic was picked from 2,4,5-T concentrations, and also tadpole T3 was picked from concentrations that exposed to 2,4,5-T, which shows a difference in hind limb development and tentacles development. Next slide, please. In conclusion, from the research, 2,4,5-T impairs growth and development in Xenopus laevis. This clearly showed by the number of fails to develop hind limb and also death recorded in Xenopus laevis that were exposed to environment containing 2,4,5-T. In this research also shows that the effect caused by herbicide 2,4,5-T have been reversed by reactions of antioxidants. As shown by the research, ascorbic acid accelerates growth and development of the Xenopus laevis, which were introduced into the environment containing both the herbicide and the antioxidant. Thank you. Next.
Many thanks, Job. So we'll take some questions across those 3 presentations. I think, Dan, you have some questions.
Yeah, I've had a few come through in the Q&A. So I have a question from Grace to Marietta, which is she's asking whether you measured mercury as well.
Let me just, sorry, I didn't see, I don't have the list in front of me right now. Just give me a minute. Mercury. Yes, we did.
Okay.
Yes, we did.
And I have another question here for you from Andy Kundi, which is, what is the typical hourly sample throughput on your EDXRF system, and how do its detection limits compare with the WDXRF systems?
The first one, the instrument is designed in such a way that the time can be optimized depending on the accuracy and the precision you need. So obviously the lower you need, the longer you have to read, but typically we're talking 5 to 10 minutes a sample at very low concentrations and about 1 minute to 3 minutes at higher concentrations. So for traces, I would say 5 to 10 minutes per sample, which will give you between 12 and 6 samples an hour. And then the second question was on the limits of detection on wavelength dispersive instruments. Energy dispersive instruments, traditionally on the lighter elements, which is from sodium up to titanium, its performance is not as good as the wavelength dispersive instruments. But all the elements above with a higher weight than titanium, normally we'd find we have a little bit better of the detection limits for those elements. And that's normally your heavy metals and those kind of elements.
Okay, thank you. Those are all the questions that I have in the Q&A. I did see Tai Cheng's hand go up at one point. Michael, have you got other hands?
I cannot see any hands up for questions.
Tai Cheng, did you want to say something?
He hasn't put his hand up.
We've got a new question in the Q&A.
We have a new question in the Q&A, Dan. From Felix.
Felix Onyije, thanks, Aki. Based on your presentation, you have an overview of the various rice regions in Nigeria. Which of them produces the most nutritious?
The presentation is on the rice from Itoiki, not for the entire region. But what we have discovered from what we have done is the soil quality have the implication on the quantity or the quantum of nutritional values in the rice grains from the various areas. For instance, as you have seen, the one from Itoiki, the rice seems to be deficient in calcium. Meanwhile, the one that is obtained from Ofada axis is especially very rich in calcium. And so it depending on the region and depending on the soil types on which this rice is cultivated, that actually affects the nutritional quality of this rice.
Okay, and I have one more question for you here from Kenbinkosi Mbedzi, which is, how can rice genotypes influence rice tolerance, sensitivity, and nutrient and element transfer?
Of course, it will have a lot of effects. The rice genotype will have effect on the tolerance to pollution or the capacity to absorb or not to selectively absorb some elements. So the genotype will, of course, have a great influence on it.
Okay, thank you.
Yeah, I think that's okay for questions. Many thanks to the panel, unless you have one, Dan, to ask. I think many thanks to the speakers today.
So there is one more that's come through.
Oh, okay.
From Grace to Job. Did you look at possible interactions of the herbicide with other chemicals or sediment or water?
No, I was interested in the reducing the impacts of the herbicide using ascorbic acid. I wanted to know how much the ascorbic acid can work on the herbicide impacts.
Okay, thank you, Job. That's everything from me.
Okay, wonderful. Many thanks to the speakers. We're just a little bit behind time. We have just over 5 minutes for a comfort break. So if you want to get yourself a cup of tea or coffee, we'll resume at 10:15 UK time. So that's about 7 minutes away. So that's enough time to make some tea. And we'll be starting with Tai Cheng An with a slightly longer presentation of 12 minutes. And you've got a nice series of presentations set up for the second half of the day. Okay, we'll see you shortly. Okay, welcome back everyone. I hope you've had enough time to make yourself some tea or coffee. So we're going to start the next session. The first presentation will be a 12-minute presentation, and we'll have 3 minutes for questions straight after that one before proceeding into a series of 3 5-minute presentations. So the first presentation we'll hear from is from Tai Cheng An in China, and he will be presenting. So Tai Cheng, you'll need to show your PowerPoint, okay? So you're controlling your PowerPoint for this one. And the title of his presentation is Determination of Metabolic Biomarkers of Occupational Exposure to E-Waste Dismantling Pollution. So when you're ready, Tai Cheng, if you can share your screen with your PowerPoint, please.
Yeah. So can you hear me?
Yeah. Okay, we can run the PowerPoint for you, yes.
But I cannot share. Sorry about that.
Yeah,
so
well,
I'm working up to all.
We haven't got your PowerPoint, so you need to use the green icon at the bottom of the screen, which says share screen.
Yeah, I find, but can just share your PPT.
We haven't got your PowerPoint. There we go. There you go.
Okay.
We could see you. Do you have two screens?
No, only one screen.
Okay.
Sorry about that.
All right. For a moment, we saw your PowerPoint.
Okay.
We now only see you.
If you click on the share screen icon.
Yeah. Just that one. Just that one.
We cannot see your slides.
Okay. How about this? Yeah.
No.
No? So I see some screens pathway. I cannot share my PPT. That's problem. I working for all afternoon for try logging.
Okay. What we might do is jump to the next
yeah,
speaker.
give me 1 second.
Have you got it? We can jump to the next speaker while you sort that out.
Okay.
And you can email.
How about this one?
That's it. Got it.
Is okay?
Right. Now run your PowerPoint.
Yeah, got it? Okay.
Now click on the PowerPoint.
So
you need to run the PowerPoint slide presentation.
Okay, you mean by myself, right?
Yeah,
okay.
Yeah, you're running it. There we go.
How about this? Yeah, no, working?
That's good. Well done. Thank you.
Okay, thank you. Finally. So can we beginning?
Yes, please begin.
Okay, thank you very much for invitation. So I'm really sorry. I'm working for 4 hours to log in the website. So yeah, today I want to give some talk about determination of metabolism by biomarker of the occupational exposure to UV dismantling pollution. Teaching and from Guangdong University of Guangzhou, China. Yeah. So this is my outline for 5 parts. As firstly, you can see introduction. So around 8% of the e-waste from Europe, maybe North American, was imported to the Asia, and about 90% is go to China at early time. Nowadays, maybe some to the Vietnam and other countries. Foreign exchange has been prohibited for entering China from since 2017. So now is but still China has many e-waste to dismantling. So when doing e-waste dismantling, so many toxic pollutants derived from e-waste post will be threatened to human health. Many small towns, they will dismantling e-waste, so they maybe have some give some expose some health threats for the the peoples. Maybe it's cancer is important to peoples. So that's got many pollutions. So still, but some organic is active, some is inactive metabolist. So the human biometer monitored is a pollutant metabolism is very important. So we know how to give some the disease for the people. Okay, so very interesting to monitor the active metabolism. So also as a lot of compound to conduct. Today we just use these 2 compounds as the target to say something about that. So human by monitor is the metabolite pollutant from e-waste is very limited because the so is very limited for the dismantling. So today we mainly as focused on the some compound is the OH, pH or TBBPA for like some flattened retardant. and some is for that one. Artificially sourced, we give some the bromide flame retardant for is the prime the phenol like that, and also some OHPH for compound. In addition, some phenol compound are from the artificial source and also from the industry. So urine is the one of the no investment by indicator for human exposure to organic compound. So we do a lot of work. So we find that both artificial phenol and metabolic the pollutant will be eliminated by the urals. So that problems is how to stimulate the determine the multiple class of the phenol in human urals. So firstly, we need develop the methods to determine the many kind of the phenol compound in human urals. You used some LCMS like many compound TCS, BP, BPA as the bromide phenol and the OHPD, PBDE and the OHPH like that to evaluate the environmental pollution exposure for peoples, to screen the potential urine biomarker for occupied exposures to multiple compound. So as the mainly supported a more comprehensive health risk assessment for human exposures to multiple compound. So firstly, we need optimize the mobile first is to get the good separation for many compound. Challenge is to separate chromatography separation of the bromide is the flattened written is the sooner is difficult, but finally we get the good separation by the methanol or also some of the acid nitride is the compound as the solution. And we can say as
Okay, we seem to have lost Tai Cheng. Are you there,
okay.
Tai Cheng?
And ammonia acetate. So we get very good as
Tai Cheng, sorry, the sharing has stopped. You've stopped sharing your screen.
Sorry.
You need to reshare, I think.
Oh, reshare. Okay. Okay. Sorry. Today not work. Okay, give me. Okay. Okay, no. Is okay?
That's good. Okay, you have 5 minutes from now.
Oh, okay, thank you. Yeah. So we got the two ice pairs was used for quantified is the bromide phenol, get the good HPLC separation so we can get to the 38 target as. So TCI as target acid is the acid analysis is can get to the good separation. So we get to the very good with the good separation with different pKa and also SPH allotted efficiency. So we get to the very good separation for compound. And this is a protocol for over target compound. So also we use this method for the validation use a urea sample. The method should very good certify the recovery for the all 38 target analytics. So samples we use the urea sample is collected from the US dismantling areas. We get the 100 people around, so for get the people. Find as HPLC is typical as isochromatography of the 38 target is can get a result of a very, very good standard solution and get a very good separation for that. And also we get the OHPH and the TCS and find the very from two populations was compared detect the difference. OH, and the TCS as very usual as the metabolite or compound in the human body. And also we get the bromide flame retardant, and OH also is a flame retardant. We get the very good result, and the concentration of usual bromide retardant pollutant from e-waste are also very significantly higher than residents from outside. Also, we also used the GCMS analysis as the derived compound, and find S2 OH PBDE 28 as usual, or is further confirmed by a GCMS with derived method. And also we get some potential method for in the potential precursor of the BARAP have been investigated. Most of them were metabolized from PBDE. Yeah. And also get some other PBDE, and the bromide phenol is also come from a PBDE, and find which is the potential exposure biomarker for e-waste activity. Yeah, so the conclusion is a simple method was developed for stimulated analysis of the multiple cluster of the phenol in the human euro. 3 point DBI and a 4 compound was the firstly identified in the human euro from US demethylene working, and considered used a euro biomarker for occupied exposures to bromide flattened retardant. And this developed method was supported a more comprehensive health risk assessment for human exposures to multiple compounds. So we need to do more works for battery for assessment of people's health. And this kind of paper is just published for EST later as the 7th issue. And thanks for your attention. Sorry about so my as quickly topic. Yeah, thank you very much.
Thanks very much, Tai Cheng. We have time for 2 questions max. I have none in the Q&A. Is anybody, Michael, raising their hand? Don't see any. Okay, so I have a question of my own, Tai Cheng.
Yeah.
This is obviously a relatively new area of work, looking at e-waste exposure. Are there any plans to put these biomarkers into national surveys to establish reference values?
Yeah. So I think your question is very good. So I try to use some especially over Unicode some biomarkers to just if you use biomarker, we can just test the people is used supply that we can get the biomarker, and we can get the biomarker pollution and the level is if we get the pollution level or concentration of biomarker, we can know how about the exposure from e-waste from the everywhere people, even use the European and American people. But I try to use the different area to use this good develop the method to use the different area. I just developed this method from China, and I'm not validation the other areas, dismantling e-waste exposure e-waste areas. Yeah.
Thanks, Tai Cheng. I think we have to move on.
Yeah. Okay.
Okay, let's move to the next 3. Oh,
thank you. Yeah.
Thank you, Tai Cheng. Thanks very much. So we're going to move to a series of 3 5-minute presentations. I noticed there is a question for Tai Cheng from Adipo Sano. Perhaps you can connect offline. So we'll move to the next 3 presentations. Again, we'll take the questions for all 3 presentations afterwards. There's a 10-minute slot for that. We'll move to Mary Odukuya in Nigeria, and her presentation is entitled Contamination and Health Risk Assessment of Mercury from Soil at Artisanal Gold Mining and Processing Sites in Central Nigeria. So over to you, Mary.
Yes, I'm with you. Can you hear me? Hello, Michael.
Yes, loud and clear.
Yeah. Good morning, everyone. I'm so glad to be part of this first online conference. The title is as shown on the slide. Next slide, please. Yeah, why this research? We all know that one of the adverse effects linked with artisanal small-scale mining of gold is the use of mercury for gold processing. And mercury can be released into the environment from the gold amalgamation and tailing process. And we all know that mercury is a very toxic element that can affect human health in so many negative ways. So to carry out this research, soil samples were taken from the mining site, and the location of the study area is located within the central part of Nigeria, which is Niger State. And the entire state is actually seated on a very huge deposit of gold. So 30 soil samples, which include all samples, agric soil and mine waste were collected from the study area. And the concentration of mercury was determined using DMA mercury analyzer method. So from the result, the level of soil contamination were determined. Also the health risk in assessment of mercury in adults and children within the study area were also determined. Next slide, please. From the results, next slide, please. The concentration of mercury in most of the soil samples were above cluster average value, and the USEPA residential soil screening level, which were used for as background value. And actually, the concentration were as high as 100 times the USEPA residential soil screening level to show the high value of the mercury in the study area. Next slide, please. Also, the mine waste show higher concentration compared to agric soil and the ore samples. Also, to calculate the contamination indices using enrichment factor, geoaccumulation index, and pollution index. So the contamination indices were calculated based on those three factors. And from the results, 70% of both the ore samples and agric soil were between moderate to very high level of pollution. In fact, the 100% of the mine waste were between moderate to very high level of pollution, while 30% of both the ore samples and the agric soil were within low pollution. And the level of pollution followed the trend of mine waste, showed the highest pollution, followed by agric soil, while the ore samples were the least polluted in the soil study area. Next slide, please. So in addition to this, the health risk index of mercury in the study area were also calculated using 4 exposure routes, which are vapor, injection, derma, and inhalation. And from the results, we discovered that exposure from the vapor and injection contributed highest to the non-health risk carcinogenic health risk index in the study area, while the contribution from the derma and inhalation were very minimal. Also, the non-carcinogenic health risk index for mercury in the mine waste, agric soil, and the ore samples determined in both adults and children show very high non-carcinogenic health risk index. They were far ahead of 1, which is a safe level. And this shows that the mercury can pose a serious non-carcinogenic health risk index in the soil of the study area. So to buttress that point also, the bioaccessibility index was used to calculate the bioaccessible hazard quotient. Please, next slide, please.
You have 1 minute, Mary.
Next slide, next slide. Bioaccessible, yeah. From the bioaccessible quotients, the results range between 0.005 to 4.06, which also is greater than 1. And the value is also posed that mercury poses a serious health risk impact in the study area. But the result calculated from hazard quotient index is lower than that of normal health risk index, so which is much more reliable information to calculate the health risk index in the study area. So the pictures you are seeing on the screen is just the process that they go through in the study area for gold processing. The first picture is the mine site, the mine site that we have in the study area. So you could see the processing of washing gold. You can actually wash 25 kilo gold ore, depending on how mineralized the gold ore is. And that can cost between $25 to $20 in price. So after the washing, the amalgam formed from the gold ore and the mercury will be burned here openly to get rid of the mercury, while the remaining gold that is well sorted for will be.
Mary, I'm going to have to ask you to wrap up
Will
as
be picked
quickly
up
as
at the end of
possible.
the day. We could see the burning in the atmosphere. Yeah, the mercury is being evaporated into the atmosphere. And we can see from the mining site, women, men, children, all over. So the rate of the impact of the mercury is huge. Thank you so much for listening. Yeah, I'm done. Thank you for listening.
Many thanks, Mary. If you can stay online, it's a very interesting talk, and we'll come back to questions after all three are presented. So we move next to Felix Onyeji. Sorry if I've mispronounced your name. And he's currently in France. He's going to talk about a systematic review of cancer among petroleum industry workers. Over to you, Felix.
Hello, everyone. Can you hear me?
Yes, loud and clear.
Felix Onyeji, a postdoc at the Section of Environment and Radiation, International Agency for Research on Cancer, Lyon, France. I'm presenting a systematic review of cancer among petroleum industry workers. Next slide, please. The petroleum industry is basically divided into three streams: the up, mid, and downstreams. The upstream is responsible for exploration and production of oil, both offshore as well as onshore, while the midstream is responsible for storage as well as transportation of the oil to the downstream, which is the refinery, where the oil is refined and then distributed. Next slide, please. Our objective is to evaluate the cancer outcome of epidemiological studies among petroleum workers through a systematic review and meta-analysis. Next slide, please. So we carried out a systematic search on two databases, PubMed and Web of Science, and it yielded a total number of 958 articles. They were subjected to screening, and they were left with 35 articles. North America recorded more than 50% of the publication. On my right hand, sorry, you'll see percentage of publication by continent, and on my right hand, you'll see production of crude oil per day by continent. So North America recorded more than 50% of the publication, which corresponds to the level of oil production. However, there was no publication from Africa. Meanwhile, Africa produces more than 4,000 barrels of crude oil per day. Next slide, please. So we looked at the various cancer sites as well as the type, and it was observed that mesothelioma was associated to petroleum industry work, about twofold, 1.98 in mortality study, that's talking about death. We also looked at the incident study, which is occurrence of new cases. And it was observed that mesothelioma again, multiple myeloma, melanoma, urinary bladder cancer, as well as prostate cancer were associated to petroleum industry work. Next slide, please. So among the 25 different sites we looked at, 5 cancer types were associated to petroleum industry work. Like I earlier mentioned, mesothelioma, multiple myeloma, melanoma, prostate cancer, which have all been reported by previous review, except urinary bladder cancer, which is being reported for the first time as being associated to petroleum oil industry work. Next slide, please. No epidemiological publication on petroleum workers in Africa, despite large production and substantial oil pollution in residential areas. Good studies are needed in Africa, and future studies should use improved exposure assessment method. Next slide. Thank you for listening. That's the end of my presentation. Thank you.
Thank you, Felix. If you could stay online, please, and we'll take the questions after the next presentation. Thank you. It's a very interesting talk. And we move to Keo Tagawa, also based in France, I think. And
yes.
Hello, and Keo will talk about cancer risks in agricultural workers, findings from an international consortium of agricultural cohort studies. So over to you, Keo.
Hi, everyone. Thank you, Michael, for the introduction. So I'm also working at the International Agency for Research on Cancer based in Lyon, France. So in the next 5 minutes, I'm going to introduce you to AgriCo, which is an international consortium of agricultural cohort studies. So just to give you a little bit of background, so why are we interested in studying the health of agricultural workers? It's because agricultural work is one of the most hazardous occupations, along with construction and mining. The workers often work with dangerous machineries. They have intensive physical labor, and also are often exposed to hazardous substances, including pesticides, heavy metals, diesel exhaust, solvents, and so on. And some of these chemicals have been shown to increase the risk of diseases such as cancers. And some of these chemicals have been banned subsequently, but more studies are needed to better understand the long-term health effects of these substances on workers in order to improve the regulations. Next slide, please. So to further advance this field of research, AgriCo Consortium was established in 2010. Currently consists of 28 cohort studies from 12 countries highlighted on the map. The aim was really to facilitate collaboration to study not only cancers, but also other outcomes such as neurological, reproductive, and respiratory health outcomes. But since I'm involved in the cancer subgroup, I'll be talking only about cancer work. Next slide, please. So the subgroup, cancer subgroup has studied so far non-Hodgkin lymphoma, which is a cancer of the lymphatic system. So in this analysis, the one before, please. Previous slide, please. No, so this is good. Sorry. So in this analysis, the study included three large cohorts from US, France, and Norway. The exposure of interest were 14 pesticide chemical groups and 33 individual active ingredients. These were selected either because they were commonly used in these populations, or there was some evidence that it plays a role in the development of the disease. And the methods used to assess exposure differed across studies. In the US cohorts, participants self-reported use of specific active ingredients, whereas in France and Norway, we used crop exposure matrix, which relied on the information on type of crops they grew, tasks performed, and pesticide registration. Next slide, please. So these cohorts were linked to respective cancer registries, and we were able to identify 2,430 NHL cases in more than 300,000 farmers. The results were mostly null associations, But there are some modest associations for certain active ingredients, including turbifos, deltametrine, and glyphosate for NHL overall, or some specific subtypes of NHL. And we also found some inverse associations with broader groups of organochlorine insecticides and herbicides, but not with specific active ingredients. Next slide, please. So the strength of this study is that we were able to examine specific active ingredients, not just groups. And also the large size of the study, which allowed us to look at specific subtypes of NHL. Because these are very important because the biological mechanisms likely differ by disease subtype.
1 minute, Kayo.
Okay. Thank you. So the weaknesses are the likely exposure misclassification due to the use of crop exposure matrix, especially specificity. And also the analysis was only done for ever-never exposure, and we did not look at, in this analysis, we did not look at the duration or other parameters of exposure. So what's next? We're planning to improve this exposure matrix, crop exposure matrix, to reduce misclassification, and also assess secondary exposure via re-entry tasks, and apply this better exposure assessment to the future analysis of NHL and other cancers such as breast and prostate cancers. So this is the end of my presentation. I would like to thank my next slide, please. I'd like to thank my collaborators in the photo and also the organizers of SEGHLive, and thank everyone for your attention.
Okay. Many thanks, Kay. Very interesting presentation. I think Dan has some questions lined up for the 3 presentations. So we'll just bring all 3 of you back onto the screen. And then Dan, do you want to lead on the questions?
Yeah, so I've had a few come through in the Q&A. So I have a long one here from Tembinkosi Mbedzi, which I will try and, so this is for Mary. I'll try and break this into smaller questions.
Dan, we do have a hand up, so if the questions start piling in.
Okay, yeah. I'll read this one for Mary first.
Yeah.
So Mary, do you experience political unwillingness to tackle mercury release into the environment by gold artisans? And this is a comment saying that this does occur in Zimbabwe. So they see a lot of unwillingness to tackle mercury release.
Yes, absolutely. We experienced a lot of difficulties in dealing with the artisans, especially with regard to mercury from this part of the world as well. And as you know, that mercury is becoming a global problem now. In fact, there was a convention in Minamata, I think sometime in 2017, to eradicate the use of mercury in gold processing. So they are aware of that, and so they are not very friendly. We had to go through the community leaders, give them some souvenirs before they could even agree to talk to us or to allow us to take some samples. So yes, absolutely, yeah. We experienced the same during the field work.
Thank you, Mary. I have a question here for Felix from Lanian Temitope, which is, did you study petroleum workers that are mainly on the field offshore or those in the office?
Okay, thank you for the question. What we did was a systematic review and meta-analysis. The individual studies did. They studied petroleum workers on the field, both onshore and offshore. Some papers stratified them, others did not. And that was why we recommended that a better assessment method should be applied, because you can't study petroleum workers, exposure to petroleum on petroleum workers, and you include both secretaries, you include both rig workers. Of course, the exposure will be different, so it should be better stratified, segmented for better understanding. Thank you.
Thanks, Felix. And I have one here for Kayo from Gillian Gibson, which is, thank you, Kayo. Glyphosate is currently under review. It appears on your list as a problem. Should it be banned in your opinion?
So this is a very difficult question, but currently, according to IARC monographs, it's classified as 2A because limited evidence on cancer in humans, and but sufficient evidence on cancer in experimental animals. So in this agrico work, as I mentioned, we acknowledge that there are some limitations in terms of exposure assessment. So this crop exposure matrix often it's used in many studies and have produced very meaningful results, but we acknowledge that this creates misclassification of exposure, and we are planning to improve that for future analysis to have a better understanding of the association between pesticide, glyphosate, or other pesticides in relation to NHL overall, and also specific subtypes of diseases. So in my opinion, we would need to look further in detail, and we need more studies, more evidence from other studies as well.
Thank you, Kayo. Michael, some hands up?
We had hands up from Lydia Alaka in Kenya and Belinda Kininga. So I'll just connect. Where we are, Lydia.
The question has already been answered. Thank you.
Okay, great. Thank you. So we'll try Belinda Kininga. Let's just connect Belinda. Belinda, if you unmute yourself, you can ask your question. And if you can say who your question is to at the beginning, please.
Okay, my question was for Kayo, but I think it's already been tackled. I wanted to find out on glyphosate because it's actively being used in Zambia and I think in most Southern African countries, but I think it's been answered already.
Okay, great, wonderful. Thank you. I think, Dan, you have one question from Maureen Ondeo in Kenya there.
Yeah, so this is...
She's got her hand up, so actually we can connect her and she can ask it.
Okay.
If I can find her in the list. Okay, you've been connected, Maureen. Can you say who your question is for, please?
Thank you. Actually, I posted mine in the Q&A, but I can still read it. Thanks, Mary, for the great presentation. Notably, your research is focused on mercury. And I was just wondering if other pollutants also occur in your area of study, and probably their environmental and health implications. Maybe or synergistically, or even in determining the overall hazards and the risks in that area. Yes, absolutely. There are so many other pollution with regard to trace element, toxic element like lead, cadmium, but because this is just a 5-minute talk, so the focus was just on mercury. So there are other, the study even involved water samples and stream sediments. And there is future plan to also sample the plants within the community and probably take some human samples also, like blood samples, toenails, hair, and other things to see the impact on the human beings within the study area. So there are so many other pollutions apart from the mercury in the study area.
Okay, many thanks to for the questions, and we'll move on to the next session. And many thanks to the presenters, some fascinating presentations this morning. And we move into the final session for 4 5-minute presentations. So again, we'll save the questions for the end, and we'll run through them quickly. So the first of the 5-minute presentations is Chris Aura from Kenya, and his presentation is entitled At the Periphery of Gaps, Needs Assessment in Defining Lake Victoria Resource Use for Management Implications. So over to you, Chris.
Thank you, Chair. And then you've read for me the title, and then I can now move to the next slide. Thank you for that. Next slide, please. Okay, the objective of this work is a review, and we reviewed this to come up with the needs and key challenges of Lake Victoria, and thereby we have proposed a framework for addressing those challenges. Next slide. Now, in the needs, we've come up with a total or a summation of 5 needs. And the first need is on balancing conservation and development. In this, we have 3 issues that we've raised. One is on Nile Perch introduction that was done in the 1960s. And the purpose of this was for economic gain, but it has had some ecological implications that I might not mention now because of time. The other area is on cage culture development that has led to mushrooming of cages. We have about 5,000, more than 5,000 cages in the lake, which might have detrimental environmental implications. Another sub-need under balancing is tourism and other product development. You can see down there. These products are emanating from the lake, and they may have some sustainable use of the ecosystem. Next slide. The other need, of course, is climate change that we have divided into several components. You can see the table down there. And under these components, for example, a good example is on the imbalance of the inlet and outlet of the lake. The lake has about 24 inlets and 1 non-outlet, that is River Nile. So the imbalance of this, alongside increased precipitation, might have led to increase in lake level rise as shown on in the figures on the right. So that is climate change is coming up as a very important need to assess in this ecosystem. Next slide. The other aspect is on health and environment. We have to understand that Lake Victoria is one of the densely populated regions in the world. It is housing about 100 people by square kilometer. And as you understand, this comes up with some social evils and environmental implications. For example, illegal fishing and food insecurity, alongside increased pollution, as you can see down there, more than fertile water down there, which, for example, has led to proliferation. Next slide.
If you, Chris, if you just wait a moment, we lost you, and we can't hear you.
Benefits, you can see down there, the production on a yearly basis from 2015 to 2019. So these are just some of the benefits that we notice as a need among others, but it was important to highlight the fisheries benefits of the lake that has to be harmonized and discussed in terms of blue economy growth. Thank you. Next slide. The other critical need is on governance, management, and financing. And in this case, the region has had some international, regional, and national institutions and conventions that have come up. But the main need here is to review the duplication and the role of these institutions and to see how we can govern the lake together to achieve an improved lake ecosystem as well as fisheries. Finally,
one minute, slide. Chris.
Thank you. The next slide, please. This one is on conclusively, therefore, for us to have a well-managed and sustainable lake ecosystem, we need to use science, that is the research findings, for example, biomass among others, and diplomacy enforcement because it's a shared transitional aquatic ecosystem, as well as capacity building of the relevant stakeholders. And this will lead to promoted ecosystem health and sustainable fishery. Finally, to the next slide, I want to say thank you, SEGH Live and my listeners. Thank you for listening. Thank you.
Many thanks, Chris. If you can stay online for questions at the end of this session. Just one administration note. Deepo Asano, you're the last in this session. Can you just WhatsApp Olivier Humphrey and tell him which ID you're using? You're logged in currently with 3 IDs and we don't know which one to go live with. Okay, so we'll go to the next presentation from Collins Unguri in Kenya, and his presentation is entitled Hepatic Polychlorinated Biphenyl Congeners Contamination of Selected, you might have to pronounce this, it's fish of Tana River, Kenya. You'll have to pronounce that for me. Over to you, Collins.
Thank you very much. The word is ichthyofauna, and I think with that, the title is clear enough. I have a number of co-contributors to this work listed there. Next slide, please. Could you please move to, yes, a little background on PCBs. These are synthetic compounds that were widely used until the year 1979. That's the beginning of the ban on production of PCBs in the US, and then came the Stockholm Convention much later, because they were found to be quite toxic and posed environmental risks to human health. Human and environmental health risks. PCBs were widely used as dielectric, as coolants in transformers and many other industrial applications. And Tana River is the longest river in Kenya and drains into the Indian Ocean. The river is used very much in economically, and the most prominent use is the generation of electricity from what we call here in Kenya the 7 Fork scheme, cascaded dams downstream, forming 7 different dams, most of which are used for production of electricity. The most prominent of which are Masinga and Kamburu. So we focused in these 2 reservoirs to try to see the extent of polychlorinated biphenyl residue availability and uptake by fish, resident fish in those environments. Because we realize that most of the available information on PCB released into the environment are from outside this region. So there's a very big gap in terms of how much of PCBs are in the environment, even after the ban on production and use of these compounds. Next slide, please. So we used 2 fish species as candidates. One is the Clarias garipinus, which feeds us at the very top of the food chain in this environment. And then Oreochromis spirulus, which is a herbivore. So this made it easy for comparison and assessment of possible bioaccumulation within the food chain. Liver samples were obtained from these fishes and analyzed through standard methods of extraction and quantitation using gas chromatography and MSD. And we use the Kojina method of assessment. There are more than one ways of assessing PCB contamination, and the Kojina assessment was the best suitable one for this case. Next slide, please.
You have 1 minute, Collins.
Thank you. So these are the summaries of the main results, and you will see that we have all the 7 criteria PCB Kojinas present in these environments, and Masinga Dam, which is the most upstream, appeared to have more PCBs than Kamburu, which is downstream. We also noticed that the most prominent Kojinas are PCB 52 and 153, which are the most dominant in both fish species. Next slide, please. So we also compared this data with previously published data from elsewhere in the world and also within this region. And we also looked at the FDA's and FAO's guidelines on thresholds for levels of PCBs in food, fish, and whereas the levels recorded here fell below the FDA's guideline on fish, there was very high for the FAO's daily allowable threshold for intake by human beings. Next slide, please. So we conclude that the levels of PCBs in fish were comparable to figures recorded previously in other environments, and the current levels can be said to be a bit safe because in the figures which we used in this comparison, others were alarmingly high. Clarias garipinas recorded more PCBs as expected because it's a carnivore and at the top of the food chain. And Masinga Dam appeared to have more PCBs compared to Kamburu. Then the levels indicate that the fish may be safe, but continued exposure by eating may pose serious health risks to the people in these environments. Thank you very much.
Many thanks, Chris. Very interesting talk. Again, if you can stay around, and we'll bring all of you back on screen at the end of this series of presentations. And we move to the next presentation. Taki Öztürk is based in Turkey, and his presentation is entitled "Direct Determination of Inorganic Carbon to Accelerate, Ease and Simplify the Analysis of Graphitic Carbon." So over to you.
Okay, thank you very much for this opportunity, Dr. Watts and SEGH. Next slide, please. So we are a young company and funded by the fund of Turkish Scientific and Technological Research Council of Turkey in 2015. Our objective is to find some problems in the laboratories and develop sophisticated solutions, analysis techniques for these problems. In this work, we collaborated with General Directorate of Mineral Research and Exploration, which is shortly MTA. MTA is a research organization that provides data to improve mining sector and offers infrastructure services, carries out the task of exploring the mineral resources of Turkey and contributing to economy, and sets up campsites and provides part of labor and equipment locally all around the Turkey. Next slide, please. Problem is, graphite become very important raw material for the technology today for industry, and graphitic carbon should be determined in order to understand the potential of the deposit. graphitic samples contains mainly 3 types of carbon, which is inorganic carbon, graphitic carbon, and organic carbon. So before analyzing, determining the graphitic carbon, inorganic carbon and organic carbon should be removed. And this removal step is very time consuming, reagent consuming, and error prone actually. Next slide, please. So this is the current experimental procedures that is applied by MTA. It's a 5-step procedures, and in the step 3 and 4, it is the rate determining step actually, and acid leaching, washing, filtration to remove inorganic carbon from the sample, and at the end of it, in the step 4, the drying procedure takes a lot of time. So in the next slide please, we proposed a direct analysis of inorganic carbon instead of removing it. We develop an instrument for this, and by analyzing inorganic carbon directly, at the end of it, you just make a calculation with the results from the element analyzer. You get directly the results of graphitic carbon. Next slide, please. How we do it? We weigh up to half gram of sample into a vial. We inject acid, 10 milliliter of molarity hydrochloric acid, and 45 minutes is wait time. And we can do a series of vials, samples in parallel. At the end, the carbon dioxide is at the headspace of the vial. We load these vials into the autosampler in our instrument, and then the instrument takes all those carbon dioxides and analyze unattendedly one by one. Briefly, it takes 1 minute for each sample to get the result of inorganic carbon.
1 minute, Tachi.
Next slide, please. So these are some calibration curve, repeatability tests, and different carbonate sources we did, and the results are quite good for us. Next slide, please. So calibration was good. We have a good linearity. Validation is done with another type of carbonate, and the recovery is okay. The CRM studies were completed, and the results were consistent with the previous procedure. And the proposed method with our analyzer is replaced with the old method, and up to now 3,000 graphitic samples were analyzed by MTA. Next slide, please. So thank you for your time. This is the instrument we use for the analysis of inorganic carbon. Thank you.
Okay, many thanks for your presentation. Again, if you can just stay online, please, and we'll present questions to all of you after the next presentation. Okay, so the next presentation is from Adipo Asano in Kenya, and his presentation is entitled Multi-Elemental Survey at Lake Victoria Basin Heralds Environmental Management Related Nutritional Deficiency Crisis. So over to you, Adipo.
Thank you so much for the introduction. This study was carried in collaboration of Kenyan and British institutions. Next slide. The intractable nutritional insufficiency in developing nations is exacerbated by emerging anthropogenic activities on the landscape and poor land management that leads to soil erosion, acidification, nutrient leaching, loss of organic matter. Recent rapid ecological changes in Lake Victoria to a highly eutrophic water body provide evidence of the drastic changes in the catchment. Physical and chemical conditions, for example, pH and the organic matter content, influence the dynamics of soil to plant transfer of nutritional elements or mobilization of potentially toxic elements. Next slide. We carried our study in Western Kenya, And actually we covered the whole area until the southern part of the lake as well. Next slide. A multi-elemental baseline survey. A multi-elemental baseline survey of key foodstuff was carried out on the basin of the Wynnum Gulf of Lake Victoria. Open source maps.me software for mobile telephones was used to ensure spatial spread of 380 sampling stations across the basin. Samples of soil, water, and food were analyzed for 58 elements. Physical-chemical parameters of soil and water was conducted in situ. The calcareous status and the total carbon was determined and related to the concentrations of the elements in the different food plants. Based on integrated food balance sheet from East African region, per capita daily intake of microelements and exposure to potentially toxic elements were estimated. Next slide. Yeah, we did our studies both in the field and did some preparation in our local laboratory and did further analysis in British laboratory. Next slide. This study revealed significant risk deficiencies of selenium, zinc, calcium, and iodine of up to 100%, and potentially toxic element concentrations exceeded the European guideline values. For example, chromium was more than 100 milligrams per kilogram in 23% of the soils. For many elements, and for many elements, in 23% of the soils for many elements. Increased acidity and non-calcareous status impacted negatively on the level of essential elements, for example, selenium. Next slide. Yeah, I used colors to show ratios of concentration of various elements from soil to plant. Red indicating the highest ratio in calcareous status, where red represents calcareous status, where calcareous status confers more than 2 times more concentration than non-calcareous status.
1 minute, Adipo.
Blue was the least. So as you can see, the macro elements, for micro elements, the calcareous status seems to confer more transfer of macro elements. And when you look at the essential elements, the color is blue. So that calcareous status conferred much less transfer from soil to the plants. Next slide. Whereas the potential toxic elements, for example, lead and chromium, were accumulated more in non-calcareous soils, a comparison of concentrations in the soil and plant tissues reveal varied but higher rates of uptake of macro and micronutrients, with the latter showing relatively much higher uptake than the former for both the types of soil. However, based on the ratios of uptake, calcareous soils supported higher relative rate of uptake for macro elements than micro elements. Amendments of calcareous status of soils tailored to deficient elements is required. Uptake of iron and magnesium is facilitated in non-calcareous soils, while selenium and zinc are taken up more by plants in calcareous soils. The different plant crops, especially the green leafy vegetables, present opportunities for dietary supply of major nutritional elements, for example, selenium. Maize, which forms 80% of the bulk daily food, does not supply adequate daily intake of most nutrients. Therefore, the hitherto unknown hidden hunger arising from low supply of dietary micronutrients may already be impacting negatively on the health among the study populations, and an understanding of unassociated anthropogenic factors would assist in designing appropriate interventions for this crisis that is already upcoming in the Lake region. Thank you, that's the end.
Many thanks, Adipo. So we'll take some questions to the last 4 presentations. If we'll just bring everyone up on screen at the same time. I can see, Dan, you've got a couple of questions waiting already. Please do raise your hands if you want to put a question direct to the speakers. We're running well to time, so that's good. So we have time for questions. Are we bringing? Yes. We're bringing the others back. Are we on? Yeah. Okay. Yeah. Great, Dan. Do you want to lead on the questions?
Yeah. So I have well, a comment and a question from Alex Stewart in the Q&A. So this is for Adipo. Alex says, first of all, Adipo, that's a lot of work. And he's then said, how did you decide that iodine deficiency existed? What standard did you use for comparison?
Yeah, we did the measurement of iodine based on the WHO standard.
Okay, so you've compared it to the
WHO blood level standard. I mean, for the plants,
Alex is raising his hand, so I'm just going to allow him to talk as well.
Yeah, so I thought you were doing, thanks Adipo. Yeah, I found that very interesting. If I understand you correctly, you were doing soil iodine.
Oh yes, yeah.
There is, I'm unaware of any soil iodine standards, so I'm interested in knowing how you did that.
Well, based on estimated daily intake, and we estimated how much food was taken, and then estimated how much of that would be taken up by a human per day, and then based the total uptake compared to the WHO requirements, the daily intake. Requirement.
Okay. I look forward to seeing your paper.
Yeah. The paper was actually out last year, so we do have urine data to accompany that as well.
Oh, right. Okay, is that right?
So there are 2 papers. There's all of the data for dietary uptakes in scientific reports, and then the urinary iodine data is in environmental geochemistry and health.
Thanks.
Okay.
I haven't caught up with those.
Any more questions? Oh, there are 2 hands up. Let's just see who has. So we have Saeed Ahmad.
Hello.
Hello.
Oh, hi, Adipo. It's a great presentation. I have got a comment / kind of a question for you. You have shown that maize provide quite a lot of calorific intake, daily calorific intake in your study area, and the selenium concentration is quite low. My comment is we have kind of done a similar study in Pakistan. Obviously, Michael and Alex were part of this study. So we have noticed that selenate works quite well in calcareous soil for biofortification. So I think it might be something if you would like to consider for your future studies, if you want to do biofortification. We did try selenite as well, but selenite didn't work very well, though it should be working because selenite can be retained at high pH soil. So I was just commenting if you would like to consider it in future.
Oh, that's very important for us. I think. Thank you so much for that comment. We'll try to take that into consideration.
Yeah, and I have got another comment with the iodine. I know leafy vegetables are great for iodine uptake, and cereal crops are not, as far as we know. But again, we have to look at how much leafy vegetable contribute to a daily food intake. Like, is it the same intake as a cereal crop? So probably I don't know, but in my opinion, it may not be the best option. So other options, exploring other options like iodized salt or other probably could be. There are other experts who can comment, probably Alex, but in my opinion, probably that will be the best option.
Actually, we did not come up with a conclusion on what is the best strategy for correction of any anomaly. Of course, iodine in salts is already, our salts are already iodized, and in some cases we find there are studies that show that there is excessive intake of iodine from already fortification.
Okay, all right, thank you.
I think, Adipa, you're right. There are as many people with excess iodine intake as there were deficient iodine intake. And so if you consider dairy and meat intake as well, that's good sources of iodine.
Yeah.
Yeah. Leafy vegetables are a very small quantity of the diet overall, but a lot of the iodine on the leafy vegetables may well be dust or rain splatter from the soil. Do we have other questions outstanding?
So I have a question, and I'd like to give both Chris and Collins the opportunity to answer this one. So both of your work focuses on a very important resource in Kenya. What are the who are the most important stakeholders locally that you can communicate your findings to?
Thank you.
Thank you for the Collins to go first.
No, I wanted to give you the opportunity to respond to that question.
Thank you for the question, moderator. Lake Victoria has a good number of stakeholders running or starting with the policymakers, that is managers, maybe at the government level, all the way from the principal secretary of fisheries, all down to a fisheries officer. And then we do also have international stakeholders because it's a transboundary lake. In this case, we have Lake Victoria Fisheries Organization and other non-government organizations related to it, to the lake. And then we do also have non-governmental organizations, so many of them around the lake, in addition to fishers themselves, in addition to lake users like cage culture farmers, in addition to cooperatives like beach management units around the lake. And in fact, in general, we are talking about the entire lake catchment that is starting upstream, downstream, from all the inhabitants within this catchment that I believe is about 680,000 square kilometers of the lake. So in essence, this information would be important to everyone because we are talking about anthropogenic activities in relation to the intrinsic acts within the lake. So it's a myriad of many stakeholders that this information would be important. Thank you.
Thanks, Chris. Collins, did you want to add anything?
Not really. Maybe the only, if I got your question well, you had also wanted to know how we communicate these findings to them.
Exactly.
And,
yeah.
To the stakeholders. Yes, after every any outcome in research, we normally prepare fact sheets, policy briefs, which we share with stakeholders. We try to reach them out and give them this information in summarized and simplified forms. But sometimes we have also organized workshops where we interact with the stakeholder communities one-on-one, where we respond, we first present these findings and then respond to any other issues that may arise out of this, or any questions that they have. And there are many other ways by which we interact with them and share our findings, but those are the main ones. Oh, yes.
Thanks, Collins. I saw Andy Marriott's hand pop up very briefly.
Yeah, can you hear me at all, Chris Collins?
Yes.
Okay. Ayauri. I'm just wondering, with the questions and the answers that have been going on with the two talks, with the lake aspect, is there something else we need to look at with pollution drivers that are coming into the waters with the trace metals that are causing issues with possible antimicrobial resistance in locations where we know aquaculture cages are? Is this something else we need to put forward to the stakeholders?
Thank you, Andy, for your question. I'll try to answer this question by saying that, as you understand, last year we had a media expose on the effects of heavy metals on fish and whether the fish was safe for human consumption. And I want to thank British Geological Survey through you and Michael for sharing us this information that we used even to respond to what I may call allegations from the media on the safety of fish. Apart from this aspect, what comes out specifically of concern that we may add to our work is on cage culture and mapping of suitable sites for these cages, what we are calling the hotspots, where we expect for the community to cultivate the cages or install the cages. And in this essence, it would go a long way with the environmental impacts of these cages to the lake or to the lake ecosystem. I think this one would be a little more important, and maybe sharing this hotspot map with the possible investors on the specific cage culture locations, maybe through some online mapping that would be useful for this case. Another quite useful area to concentrate on is point sources of pollution. You understand the expose was about industries around the lake and how these industries are contributing in a way to pollution of the lake. So if we would do mapping, inventory, and monitoring of these point sources, we are talking about where they discharge their waste into the lake, and pinpoint them and define if what they are discharging is within the recommended levels. This would be important, not just to the stakeholders within, but also to the government. And perhaps I would also request Collins if was an additional point to add. Thank you.
Thank you, Dr. Aura, for that response. I think that's satisfactory. I wouldn't have much to add.
Okay, thank you very much, guys. It's interesting because of the flooding that you've had recently all around the lake. This should be a real serious issue now with these pollution drivers coming into the lake. But I also think the recent TV program on the national Kenyan TV highlighted the problems around the lake and how pollution is slowly causing more issues. Thank you very much.
Thanks, Andy. I have a question for Tachi about your equipment. And you said you're a relatively new company. I just wonder where you are selling your equipment to. How new is your company, and what is your network at the moment? You have an international audience from all over the world here, so they may want to know where you are based.
Yes, we launched this product 2 years ago. We are a 5-year-old company. And we have got services in US, in Spain, in Morocco. But meanwhile, we are also discussing with other distributors in other countries. We are expanding our network. This product is developed, it's called CASIS. It's developed for soil laboratories. But we have seen for the analysis of inorganic carbon, it can be used for geological samples. Up to now, we only have 2 customers for geological application and 8 customers for soil laboratory. Who is the soil laboratory? So total of 10 instruments were already installed.
Okay. So
one of them is United States Department of Agriculture, by the way.
Okay. So
Yeah.
that's Richard Ferguson, I guess, at the USDA.
Yes.
Yeah. Okay. So you think probably research institutes or possibly industry as well?
Basically for academic purpose, yeah, for industry institutes.
Great. Okay.
Yeah, thank you.
Great. Thank you. I don't see any other questions available. So what we'll do is, we'll say thank you to the presenters for this session, and thank you for wrapping up the second day of SEGH Live, and again another diverse day of topics and presenters from various parts of the world. And Olivier Humphrey, who has been busily through both days putting the slides together and working very hard in the background and trying to solve technical problems, will give a wrap up of day 2.
Hello, everybody. Hang on.
Okay.
Last minute technical difficulties just there as well. So thank you to all the speakers and keynotes, and congratulations on such interesting talks.
Speaker.
I'd also like to thank the SEGH board for supporting the scientific organizing committee of SEGH Live. And I'd like to thank all the attendees for coming and watching and asking questions and getting involved. I think the main theme for today has been biogeochemical cycling of elements and how that impacts the health of soils, plants, organisms, and humans. It was great to hear about the range of talks, the range of work that's being conducted at IARC, and how environmental geochemistry influences human health. I think we just finished the day there, or the session there, with some talks from Kenya, and that is, of course, where we were supposed to be having our international conference this year. So special thanks to Adipo again for allowing us to access the abstracts he arranged for the conference in Kenya. I've been reading and I've seen a lot about how lockdown during COVID has accelerated a lot of behaviors, and one in particular is possibly this shift from traveling and using carbon to fly to other conferences in different countries. And I think this shift to an online conference is something that's very exciting, and something I believe a society like ours can use. So I think because we've hosted this over 2 days and we've had talks from across the globe, we can truly say we are a international society. And I hope these SEGH Live events go from strength to strength, much like the official journal of SEGH, where we've seen the impact factor increase as well. So once again, thank you to all the presenters and attendees. I think we've got a short AGM coming up soon, so please stay online.
Okay, thank you, Olivier. So just what we'll do is bring up some of the board members that are online onto the screen so we can introduce you. So as I said at the beginning, we have board members across Asia, Pacific, Middle East, Africa, Europe, and the Americas. Some of the Americas may not be online because of the time difference. So what we'll do is try and pull.
Could all the board members please raise their hand so I don't have to go and find you through the attendees list, please?
Oh wow, that was quick. That was a quick response. So we'll have a few updates from various members of the board, such as finances and membership. We have just a proportion of the membership online at the moment, and we'll give you just an update or perhaps a revision of some things that you heard yesterday about developments for the next year. We are very keen to have volunteers to take part in events. I don't know who that is. and to volunteer to support initiatives such as the Early Career Researcher Group. We are very encouraging of early career researchers to connect with one another, and Dan and Olivier have put a lot of effort into that in the last year, and that they can give a little update on that in a moment whilst we bring everyone online. Nor isn't.
What's that?
Nor isn't.
No, you sure?
Yeah. Yeah, just knock her out. So we're just seeing who's on the line.
Yes.
Sorry?
Celios.
Okay, so as I mentioned yesterday, we're approaching the, and first thing this morning, the 50th anniversary of the formation of SEGH. So in 2021, we were planning activities through this year into next. So we will have the postponed Kenya conference this time next year, and we'll plan other meetings. As I said, Vancouver is planned for a workshop. Whether it's in person or remote, we'll have to wait and see. And there'll be other initiatives. We have Maurizio Barbieri in Italy, Murtas Terek in Egypt, and Mark Button in Canada, coordinating a series of review papers from amongst the fellows and early career researchers. If people would like to volunteer to write a review paper on a particular topical theme, then we would very much welcome that. And these papers will be released as a 50th anniversary special papers over the coming year. And they will be given open access, which is quite unusual actually. They'll be given open access for several weeks. So that should help readership of your papers if you volunteer a review paper. So I'll give a little bit of information about the journal in a moment. Anthea, I think Anthea Brown is the membership and secretary and treasurer. And I think Anthea's got a little bit of information about the number of members and finances that we normally feed back to members in the AGM. So I think, Anthea, if you're ready, you can share your screen. Can you share your screen? Do you have a slide? There you go.
Yeah. Yes, okay. It's just a quick gallop through the financial situation. It's not a formal statement. It's just a snapshot of where we are at the moment. Can you see the full? Thanks, April 11. You can't. Can you actually see it, or?
Yes, we can see it. We were just losing your connection. We couldn't hear you.
Oh, okay.
You can move on to the next slide. That's okay.
And since April, we've had membership fees of about 1,500 and outgoing costs roughly of 856. So they're just rounded up figures, rounded down figures. But the bank balance yesterday was 4,151. But over the next few months, we'll have further web costs, banking costs, of course, and our main expense is the Springer Journal fees. We have to pay €20 plus 20% VAT for each member to access the journal.
Anthea, that's for the members that have selected the option for membership with Journal, yeah?
Yes, that's right. So we will be down on income this year, because we usually get sort of 3,000 to 4,000 from conferences. But the good thing is that we've had over 40 new members who've been attracted by the Zoom conference, and that takes us up to over 200 members at the moment. But of course, that changes all the time, but that's where we are at the moment. So I'll just do a quick picture of. That was the geographical spread in January 2019 after the Zambia conference. huge cohort from Africa, of course. And then in 2020, at the moment, after the Manchester conference, we've really got the biggest influence from the UK, but still a lot of members in Africa, and a spread, as Michael said earlier, of around about 35 countries, which is pretty fantastic. And going on to, I just did a quick one of the delegates for the Zoom conference this time, and a massive a group from Africa, and a lot of input from Greece as well, which is quite new and good, and France as well. So I should have done one of the speakers, because that would have been a different picture really, but I ran out of time there. And that's just the spread by the regions at the moment, but it's all very changeable. Okay, that's it.
Okay, thanks very much, Anthony. I mean, what we've seen with the change in the membership is that the Americas was quite a dominant group, wasn't it?
Yes.
Probably similar to Middle East, Asia, and so we've seen a shift of membership to Asia and Africa, haven't we? And we're trying to rebuild the Americas section. That's the current task at the moment.
Yes.
But we've had Europe as a solid sort of base of membership all through, haven't we?
Yes.
But yeah, certainly the growth areas in Africa and Asia have certainly kept the membership levels up. So what would be quite nice is if we could introduce the rest of the board that are shown on the screen. There are about 24 board members, and but I think we don't quite have every region covered. So perhaps I could go through the screens and ask each person to introduce themselves so that you can at least meet some of the board. So I'll go through in the order of my screen. And perhaps you can introduce yourself and any comments about SEGH you like. And if people would like to ask questions of any of the board, please do raise your hand and you can ask questions to anyone. Keith Torrance first, please. And then Gillian after.
Well, hello everybody, I'm Keith Torrance. I'm based currently at the University of Strathclyde in Glasgow. I've been involved with SEGH since about 2009, including a period where I was a representative for North America there. Most of my work at the moment is focused on issues with contaminated land, but I also have interests in mining, especially gold mining, and some of the health impacts from artisanal mining. I'm currently working on, for my sins, on canal sediments in Scotland, which is a new area for me, but one that's very interesting. Great blend of some geochemistry with some industrial history there.
Okay, thanks, Keith. Gillian Gibson, who is our SEGH secretary.
Indeed, thank you very much indeed. Can you hear me okay?
Yes.
Okay, thank you. Great conference. Thank you very much indeed for organising it. Really enjoyed the last couple of days. Lots of different information coming forwards. Unlike the rest of you, I'm not based in academia. I'm one of the people who goes out and uses the information which you provide as an environmental consultant. I do a lot of health impact assessment, which is involved at the planning stage and also at the regulatory phases as well. So it's interesting for me to see the information which you provide and to be able to take it and use it in earnest, if you like. Thank you.
Okay, thanks very much, Gillian. So we move on to Ariadne in Greece.
Hello. I'm a professor of geochemistry in the National Kapodistrian University of Athens, Greece. I would like to congratulate for this initiative. I think it was really great, and I was thrilled by the diversity of presentations and the thematic. And also I would like to make a comment about the increase in the Greek side of participation and the new members. I know that these members are students, so they are young people, that this was a real teaser for them. And I hope that they have a good impression after this, and they know what the society is about, and how this community is really international and deals with all these very interesting thematics around geochemistry, but also the health side of it and how these two are connected. So I would like to work more with the young researchers, and together with Keith Torrance, I think we can build up on this from now on. Congratulations again, and all the best for the future.
Many thanks, Ariadne. And I know your increase in members in Greece is probably a result of your tremendous efforts last year to host an SEGH co-hosted meeting.
Yes, but also I would like to thank the students that they got really interested in this, so they are acting themselves.
Great, they're very welcome. And if they would like to join the Early Career Research Network,
Yeah.
they're very welcome. Yeah, thank you. Okay, and next to Ophelia in Mexico. You need to unmute.
Now, can you hear me? Yes.
Yes.
Good morning in Mexico. In Mexico, it's very early in the morning. I began at 3 o'clock in the morning here. I am Ophelia Morton. I am researcher at the National University from Mexico. And I am new in the board here. And first, I want to congratulate. This was a wonderful organization. Everything was perfect. And all the talks were very interesting as well. We have to do it often in this kind of talks. I hope to like Adriana to do something in Greece. I want to try to work more with students and with other researchers in Latin America. I am trying to organize a little group in other countries in Latin America, especially in Chile. And yes, with the students, I will try to do something special too. And I hope soon we can organize something big in Mexico.
Thanks very much, Ophelia. It must be very early in the morning there. Thank you for joining us. I'm not sure when you sleep, actually. You seem to be online all the time. Yeah, I should just go back to one of Gillian's comments in that Gillian is working in the consultancy industry. So we aren't, you may see a lot of people on this panel from academia. We do very much welcome people from the commercial sector, from industry, regulatory environments. It's very much a wide audience that we welcome to SEGH, and it's very enriching to have that diversity. Okay, Anthea, would you like to add anything to your comments earlier and to introduce yourself?
My name is Anthea Brown. I'm the Membership Secretary and Treasurer. I have been doing this job for quite a while. In fact, I was first involved with SEGH back in 1990. So it's my 30-year anniversary this year. But yeah, I enjoy doing the work. I've really enjoyed the conference. It's been absolutely amazing. And I know that Michael and Olivier and Daniel have worked incredibly hard, and it shows. It's been absolutely faultless. Thank you.
Next along, Xiaosheng Zhang. If you can unmute yourself, please.
Okay.
Okay, we've got you.
Okay. Hello, everyone. I'm Xiaosheng Zhang from Ireland, from Galway. It's a very beautiful place, and I've got a new hobby, taking photos. So you can see nice photos here. But I want to see congratulations to the new board members. I think as SEGH is getting more and more international. That's in fact we have been struggling for a long time. I think 4 years ago we got a new constitution with the aim to expand it. I think initially the society was mainly American-based and then UK-based. Now it's truly international. So that's really what we want to see. And well done anyway, all those guys. And really, that's really what we want to see anyway. Well done. And I think the idea of the webinar is really nice. I think we should keep doing that. Okay.
Thank you, Chao Sheng. So we'll move along to Adipo Asano in Kenya. You need to unmute.
Oh, thank you very much. And congratulations, everybody who presented. Actually, this is way beyond what I personally expected. Okay. And I think it's so good. You challenged us yesterday that maybe some of us should take this up, and I take that challenge.
Perhaps
I would have liked us to hold a similar one, maybe a thematic one on African issues in soon, maybe before the next conference. I think it's very nice. Thank you so much for taking this risk, and I think it was worth it. Okay. I've been in SEGH from the board for the last 2 years. And I hope to give my best during the remaining term or time.
Thank you, Deepo. Could you give us some information about your interests as well, please?
About what? Can you say that again?
Your research interests, your activities.
Oh yes, my research interest. Veterinarian originally, but I've been interested so much on the effects of things, contaminants in living organisms, and that includes animals and now extended to human beings, and trying to understand the sources and effects of various compounds, both organic and inorganic. Recently, we have been looking at effects of concentrations of metals, both toxic and mostly microelements, and their distribution in the western part of Kenya. And we are trying to see the dynamics of transfer in different compartments in the environment, and the concentrations. That's what we are doing with I teach at the university, and that's the kind of research that I do right now.
Okay, great. Thank you, Adipo. And hopefully we'll all be with you in Kenya next July.
Yeah, you're all very welcome. Yeah.
Okay, great. Thank you. So we'll move to Belinda Kininga in Zambia next, please. Belinda, if you can introduce yourself and your interests.
Okay. Hello, everyone. My name is Belinda Kaninga. I'm a researcher for the Zambia Agricultural Research Institute, and I'm just finalizing my PhD studies, where I'm looking at heavy metal uptake by crops grown near mine tailings. I have been a member of SEGH for a few years now, and I'm very excited to be part of the board, because I think it offers a lot of opportunities for my career progression. And through the board, I hope to also grow the membership of SEGH, especially for early career researchers in this region, because I think there's a lot of opportunities for early careers in SEGH. So, and lastly, I'd like to congratulate the organizers of this webinar. It's been interesting, and congratulations to all the presenters for all the good presentation. I'm also very fascinated at how successful it's been, and it's gone on keeping time. I think it's a learning process for some of us. We hope to host something like this, maybe even just within the region. Thank you very much.
Great, thank you, Belinda. It's sounding like we have some more volunteers for future webinars so far, doesn't it? This certainly sounds like an African webinar coming up. I look forward to joining that one and not organising it. And I think Olivier and Dan might breathe a sigh of relief there. Thank you, Belinda. So we'll move along to Akinad Olatunji in Nigeria, please.
Yeah.
Yeah.
Good afternoon from Nigeria. My name is Akinade Olatunji. I'm an associate professor of geochemistry at the Department of Geology, University of Ibadan. Funny enough, I've been out of office for 3 months. I've been working at home, and internet connectivity from home has been very wacky. But it was interesting to have been able to be part of this SEGHlive from yesterday. It was very interesting, and I'm excited that we have that large number of participants, even from Africa. And just in line with what Belinda and Professor Dipo have said, I'm sure we should be able to leverage more on our colleagues and our students to be part of this wonderful experience moving forward. And I'm sure not far from now, we should be able to run an SEGHlive event from the African sub-region. And I must also say kudos to Humphrey and Olivia and Dan. I'm sure it's not easy working with your supervisor, driving you to make sure that everything works well. But that's a perfect experience. And for Michael, it's a fantastic job to be able to pull this through. I think we have done very, very well. And I'm extremely excited that the level of commitment of everybody to making sure that the SEGHlive event was very successful. So good to see everybody, and I hope to continue to work together to make SEGH a very vibrant society. Thank you very much.
Great, many thanks, Aki. And we'll introduce Kosei Yamaguchi in Japan, please. I can see you've lost the suit and tie. You're now on the beach, relaxing.
Sorry.
That's good. It's good. It's an informal meeting, eh?
Well, I'm Kosei Yamaguchi, geochemist and astrobiologist. So I always call myself as astrobiologist, doing everything. I'm working at the chemistry department at the Toho University near Tokyo, Japan. For environmental geochemistry, I have been working on arsenic in the contaminated area. And I just presented my talk at the beginning of the conference today. And I would like to congratulate all the board members and the speakers today. And also, I also would like to thank the organizers of this conference. This is really great. Great.
Great. Thank you, Kirsty. And thank you for opening today. Very much appreciated your presentation first thing this morning. And we'll go next to Sanya Pokhita Vermaak in the UK.
Good morning, everybody. I don't know whether you can hear me properly. I thought I'll put the background of last year's meeting up here, as that would have been happening, hopefully, if we had a real meeting, but I think the virtual meeting was a big success. My research is mainly on air pollution and air pollution trends and its impact on human health. So the SEGH for me is the best place for an environmental analytical chemist who's interested in health, because it actually does geochemistry and health. And maybe some of you as academics might find this interesting and could possibly also endorse what I'm saying. You find it really difficult to get funding if you are working in two fields. So the marriage between geochemistry and health for me is an absolute bliss. In terms of the SEGH and being on the board, I'm very honored that I've been chosen again. And my main aim is to promote SEGH and membership in academia, because I think that is one thing that we are lacking is new PCRs and introducing this even at an undergraduate level. The membership fees are really affordable for students as well as postgraduate students. And I think that is where I would like to make a contribution. I just want to congratulate everybody on the virtual webinar. It was really a good idea, and I think it went very well, especially taking it for the first time.
Okay, great. Thank you, Sonia. So I'll ask Olivier to introduce himself and his interests.
Hello everyone, my name is Olivier Humphrey. I'm an environmental chemist at the British Geological Survey. My main interests are looking at short-term micronutrient dynamics in soils and plants, but my interests are very varied. I'm also interested in looking at much larger scale soil erosion in basin scale studies and looking at how micronutrients transfer from soils to plants to humans. I've been a member of SEGH since 2016, and I'm currently the webmaster for SEGH.
Okay, thanks, Olivier. And Daniel Middleton in France.
Hi, everybody. So my name's Dan Middleton. For the last 4 years, I've been a postdoc at the International Agency for Research on Cancer in Lyon, France, where my research is focused on the causes of esophageal cancer, which has very, very high incidence rates in East Africa, among other places. Particularly interested in the possible geochemical causes. But before then, I was working actually with Michael doing my PhD on a geochemistry project looking at arsenic in drinking water. So I'm in quite a unique position to have moved from geochemistry into epidemiology. And I think if I've learned one thing, it's how important collaborations are and how important our society is to foster those kinds of collaborations. And I first went to an SEGH conference in 2014 in Newcastle. I also went to Bratislava, I went to Belgium, in Brussels, and I went to Vic Falls in Zambia. So I think I'd say to any new members, if you can, get to the conference when we can eventually do one in person. It's a really good experience.
Okay, great. Thanks, Dan. And Olivier and Dan, of course, will give you a little bit of information about the early career researchers in a moment. So you probably know I'm Michael Watts. I'm currently SEGH president, so I'm just in my second term and final term. Somebody else will need to step up in November 21. And I'm very pleased to see the international audience that has come about, and also the composition of the board as well now. And a lot of my interests are reflected in terms of environmental pathways and impact of metals on health and deficiency of micronutrients in the environment on the health endpoint. So yeah, I'm quite in a privileged position to see a few collaborators on the board. Would welcome new members to the board, certainly volunteers to undertake new initiatives. And so please don't wait to be asked for something. Please offer up new ideas. And this is very much a democratic society, and we encourage new ideas. If you would like to ask questions of the board, please do raise your hand. We have about 50 to 60% of the board online at the moment. We don't quite have everyone, but this is a good representation. So what we can do next, unless anyone else on the board has something to raise their hand and say, I've got a little bit of information just to show you next about the journal. So just let me pull up PowerPoint. So some of you will have seen this first slide. So hopefully you can see that. And no. Okay. Can I see this?
No, yeah. No, you still need to share your screen.
Oh yeah. Sorry. After all this time, I'm forgetting to share my screen. Okay. So the impact factor for our.
Shared the wrong screen.
Oh. See, I'm messing up now after 2 days. So there you go. You'll all film. Okay, so you'll see the impact factor for the SEGH official journal, Environmental Geochemistry and Health, is going very well. So in the last sort of 4 years, 2015 to 2019, 4 or 5 years, the impact factor has gone from just over 2 to almost 3.5. So it's jumped a little bit from 2018 to 19. So it's progressing very steadily. So as I mentioned yesterday, there are a lot of papers awaiting to be released, about 200, and that's largely as a result in the increase of submitted papers from about 400 or so in 2015 to over 900 in 2019. So it's quite a challenge actually clearing them, and I think one of the structural problems in the journal is issuing issues throughout the year, collections of papers. So the journal will move to ad hoc publishing, which I think will improve the submission to publication cycle, and hopefully that should improve the performance of the journal as well. And I think a lot of this new submission rate is coming from Asia and the Middle East. So Springer have agreed a few initiatives. So they have looked at early career researcher papers. So what they are now doing is when people submit a paper, they will mark the paper as whether they are an early career researcher. So based on the record for 2019, they have provided a list of 10 papers or thereabouts, and the board have voted on the best paper. And the unanimous vote was on a paper by Cuevas et al. And entitled "Impact of a Tire Fire Accident on Soil Pollution and the Use of Clay Minerals as Natural Geoindicators." So Springer are offering $300 to that prize, to that paper, the early career researcher. And that's something they will do each year. So if you are an early career researcher and you're submitting a paper to this journal, do make sure you tick the box for early career researchers, and you may be eligible for a prize in future. There are some very good papers in that collection there. So let me stop sharing the screen. So that's one of the initiatives. So the impact factor is going very well with the journal. So we have an early career researcher network, which is another initiative for the journal. Perhaps Dan or Olivier would like to give a bit more information on what you provided yesterday for those that didn't attend.
Yes, so yesterday I gave a brief introduction to the early career researcher community. In summary, it was established at the 34th International Conference at Victoria Falls in 2018 to provide a sense of community, mentorship, a pathway to publication, and fourth one escapes me. But essentially, it's a group of early career researchers defined as students or researchers who are within their last 5 years of graduating from their highest degree, and just provide somewhere where you can get some more get a bit more feel and engagement with a society. SEGH is incredibly opening and welcoming, and it's really easy for early career researchers to get in contact with the board, to even have a role on the board. I think there are a number of us present on screen at the moment who are all early career researchers. Pathways to publication with blogs on the website. As Michael just mentioned, actually publishing within the official journal for SEGH on the website. Anything else, Dan?
No, I don't think I have anything to add. I'm just conscious that I can see the number of participants starting to drop, and we haven't announced the prize yet.
Yeah. So why don't you announce the prize for the winner for the best presentation for the early career researcher and the runner-up? So Springer have provided a $250 book token to spend with Springer for the first prize, and $150 for the runner-up. It was a very tough call amongst the early career researchers. So do you want to, one of you want to announce?
Yeah, I can announce the runner-up, and Dan can announce the winner. So the runner-up with a $150 book prize for Springer was Hayley McLeod from Lakehead University in Canada. We thought her talk was excellent. The quality of the slides was fantastic. Handled questions really well, and very exciting to see where that work goes. For both the runner-up and the winner, who Dan will announce momentarily, it'd be great to see your involvement within SEGH a little bit more. And based on the success of your 5-minute talks, I think we'd be more than happy to allow you to have a much longer talk at the next SEGH Live event. So Dan, if you'd like to announce the actual winner.
Okay, so the winner, who will receive a $250 Springer book prize. And the decision for this was the clarity of the presentation, stuck to time very, very well, relevance to geochemistry and health, and potential for future involvement in the society. The prize goes to Felix Onyije from IARC. Congratulations, Felix.
Let's bring him on screen.
He's here, so I think we can get him up maybe to say a few words.
No, that's got Elliot. You've got Elliot.
Who did that?
So,
wow.
Congratulations to Felix. Well done.
Thank you, thank you, thank you. I'm happy, I'm grateful to the organizers of this conference. I mean, I'm short of words. Thank you very much. And I pledge that I will stick to SEGH and as much as possible try to bring other early career scientists to join. I must confess, this is one of the best conferences, virtual conferences I've attended within this period. It was clear, things were just well organized. Thank you very much for this award. Thank you, I'm grateful.
Yeah, thank you, Felix, and welcome to SEGH and to all of the other new members. And it sounds like there is some demand for another live webinar. So please do let us know your thoughts. You can just email us if you like. And if somebody would like to volunteer to run it, we would very much welcome that. And to pass on the baton to someone else. And regional meetings, again, maybe could be more focused, particularly on the time zones. That might be more appropriate. What we hope to do is to take a photograph of the conference attendees again today. So if people can hang on, we'll just be a few more minutes. We took a screenshot of attendees yesterday, so it'd be quite nice if we can put these within a write-up of this SEGH Live event. If you don't want your image to appear, just turn your camera off. And okay, so what would be quite nice to know is if we can get some feedback for this webinar, is if you can give us some information about, would you like it to appear again? Do you think we should have a shorter format, a longer format? Do you think it should be shorter and more frequent? So give us a little bit of useful information. It's very nice to hear the congratulations and thank yous and well done. That's great. Our egos are inflated. But if you think there's anything we could have done better, that would be also useful to know. So the three of us have learned a lot in this last week in terms of the arrangements and how we communicate information. And particularly over the last day or so, there have been some complications, but hopefully they haven't shown too much. So please do give any feedback on how we can improve this experience. Okay, Chao Sheng's just raised his hand. Okay, you just need to unmute yourself.
Yeah, I just see there's a hands up from Alex from the attendees.
Okay.
Just, yeah.
Are you making Alex live? Yeah. Are you putting
Yeah,
one?
he's live. He just needs to unmute himself.
Is that Alikos or Alex Stewart?
Hello, can you hear me?
Yes, hello.
Hello. First of all, congratulations. It was very enjoyable. And I have to thank you all, Michael, again. Well, I hate usually multi-session conferences. So this single session, it was really good because we are all sort of attending one session. And also I thank all the presenters. And I must thank also Ariadne, although she's, she transferred her eagerness to the students. That's why it was really a good surprise to see so many people being members of SEGH. And in my opinion, we should do this more regularly. I know it's very hard on the organizers, but I'm sure you can find organizers, and this is one way to increase the membership. So we must think about this. Now, some advice to non-English speaking presenters, because these are short presentations. In my opinion, it's a good idea to record your presentation and listen to your presentation in order to correct your pronunciation. So this is a good advice to all of you, and also the early career researchers. Now, I'm very particular on terminology, and I've seen some things that we don't use any longer. Geochemical data do not follow the normal Gaussian distribution. Hence, we no longer use parametric statistics. We use non-parametric statistics. So please do not use the mean and standard deviation. These parameters are now replaced by the median and median absolute deviation. We also know that geochemical data are a good example of compositional data, closed data, which need to be opened before processing. I'm not going to go into that. If anybody wants any more information, I can send them some papers. And we also no longer use the term heavy metals. This term has been replaced by potentially harmful elements or potentially toxic elements, although it is preferable to use potentially harmful elements. Now, another important terms are pollution and contamination, pollutants and contaminants. Now, when you use pollution and pollutants, you must have proof that there is harm to humans, biota, and the environment. Otherwise, you use contamination and contaminants. So please, the young researchers must update their terminology. Thank you very much for listening to me.
Great, thank you very much. Just to pick up on one of your points, we have been recording these sessions and they will be posted on the website for members to log in and access the recordings. So
that's good.
Thank you for that comment.
Thank you.
I just wonder if we should have a comment about the fellows. Gillian, did you want to, are you okay to give a quick roundup of what the fellowship scheme means? Sorry, just to drop this on you. If you just unmute yourself. And I think that's probably one of the last points.
Okay, thank you very much indeed. Yes, we set up the fellows a couple of years ago. We wanted very much to be able to recognise things which people had done on behalf of SEGH and on behalf of geochemistry more widely. We also wanted to have somewhere for people who have been with SEGH for quite some length of time to be able to demonstrate that level of leadership and to be able to have something to which the ECRs could actually aspire at some point in the future. And this foray into collaboration between the fellows and the ECRs for the publication next year is probably our first foot in the water, if you like. I'm hoping that it's going to go great guns. It seems to be developing quite nicely at the moment. I think that's probably as much as I want to say on that, unless you want to ask me anything specific.
I think that's fine, Gillian, unless somebody has a question from the audience. I think what we might do now is one last thing is to take a photo. Can we do that?
Yeah, we just promote everyone.
So get your smiles ready. relax your face, and you might need to hold your smiles for a while. As yesterday, we had to take a few screenshots because there were so many attendees to fit on the screen. So Olivier is just putting everyone on screen.
And Dan can help.
And Dan, can you just help do that? Help Olivier do that. I think he is doing that. Now we can put some faces to the names. That's great. Or we can see some people would like to be anonymous, or their camera isn't working. So we'll give you a warning when the photo is taken. So brush your hair back, get your smiles ready, get the lighting corrected so that we can see you. We're almost there, just the last few to add. Okay, I think we have everyone, yeah? So, all right, get your smiles ready. Cheese or whichever word you use. Ready? 1, 2, 3. Smile. Cheers. Keep holding the smile. He's got to take a few photos. It's like a wedding. Except no drink, is there? That's the problem. So a challenge for the early career researchers, perhaps for the next live webinar, you can think of a social activity at the very end. Maybe a quiz or something like that.
Brilliant.
Great, thank you. You can relax your smiles. Hold on. some looks of relief there. And I think just as a final point, just many thanks to all of the contributors, particularly from the Kenyan contingent for providing all of the information for the abstracts submitted to Kenya 2020. That gave us a massive head start, and there's no way we could have organized this meeting so quickly without the head start. Thank you to the participants that have spoken and been very helpful and cooperative in putting this schedule together. And many thanks to the attendees for your interest, and to new members. Welcome to SEGH, and we hope to see you again. We think we may run another meeting at the beginning of October. We'll just see how quickly we can arrange everything. So keep looking at the SEGH website, and updates will go there. If you feel free to write any articles for the website and some news articles, it might be about your latest project or paper, and it will help you to communicate with the rest of the membership. And we will let you know when the recordings of this meeting are online, and you can log into the website. Okay, many thanks for your attention, and take care everyone, and hopefully we'll see you again soon. Okay, goodbye.